Hello, hi, namaskar everyone. So I welcome you all in this all formula revision session where before your IIT JEE we are revising all the formulae of IIT JEE Mathematics. So let's get started. Sailesh is asking the duration of the class. Yes, Sailesh, I'll try to bind it as soon as possible. But yes, you do understand, we'll be revising all the formulae. I'll be taking you through the entire mathematics, the formulae and everything. So we'll be taking care of all those things in this particular session. So without any delay, let's get started. Before we start this session, I hope you know that we have started our WhatsApp channel as well, from where you can get all the updates. So if you wish to subscribe to our channel, you can scan the QR codes visible on the screen and you can follow our channel. With that, let's start with calculus. If I could simply give you that what all we'll be covering in this session. So we'll be starting with calculus. I'll be making you revise all the concepts, all the formulae basically of calculus. After calculus, we'll go for vectors in 3D. Once we are done with vectors in 3D, we'll go for algebra, and then after this, I think we'll go towards trigo, and then in the end, we'll culminate this session with coordinate geometry. So great. So I think everybody has joined and I think I'm clearly audible and visible. Just give me a quick thumbs up so that I can straight away start with this session. Are we clearly audible and visible, students? Just give me a quick response so that we can continue with our session. So if I could make you revise the basic standard decent formulae from differentiation or the derivatives, they all are there with you. I hope you know that the derivative of constant is 0, derivative of x to the power is x to the nx to the power n minus 1, derivative of mod x. This is something you all got to remember, that derivative of mod x, you need to take care of it. It is always x upon mod x. A lot of students are asking how long it is. As of now, really, it is tough to culminate or say that how long will it take to conclude this session. But yes, somewhere around or somewhere before 4 to 5, I'll try to culminate it. But yes, it will be there until possibly till 5 o'clock. This is my assumption here. But again, I'll try to bind it before 5 o'clock. Possibly, yes. So let's move ahead with that. I hope the next conclusion, e to the power x is one of those beautiful functions which is always e to the power x even after differentiation or integration. But something very crucial again, a to the power x when differentiated gives you a to the power x log a. Moving ahead with that, something simple and straightforward, trigonometric functions derivative, sin x, cos x and tan x, you all remember. Why should you remember them? Because in integration also you use inverse of them. For example, when you integrate cos x square x, what you get is minus cot x. So this is how differentiation helps you in remembering the formula of integration as well. So the well versed you are with these formulae, you can easily predict or work out the formula of integration as well. So if you wish to take the screenshot of this slide, you can. And with that, let's move ahead. The next set of formulae, the inverse trigonometric functions, they are more crucial ones because in integration, you are asked to deal with something like this, 1 upon under root over 1 minus x square. So when this kind of expression comes into picture, you got to remember its integration will be sine inverse x. And there you should say that derivative of sine inverse x will be 1 upon under root 1 minus x square. The error which a lot of students commit here is that they forget that here what matters the most is that x should lie between minus 1 and 1. Similarly, when you talk about the expression 1 upon 1 plus x square, we know its integration is always tan inverse x. So yes, derivative of tan inverse x will be 1 upon 1 plus x square. Moving ahead with that, few more formulae are there. I hope you can see them and understand. And with that, we can straight away get started or move towards the next part of this. The next part is, yes, the two very important or straightforward formulae, the product formula and the quotient formula for derivatives. Product formula we all know, but let's say there are more than two functions are there in terms of product. Then how do you apply the product formula? For two functions we know, derivative of first function times second function it is plus derivative of second function times first function as it is. But let's say if there are three or more functions, then what functionality, what method do you use? That's what we'll be discussing here. So idea is simple. Let's say there are three functions fx, gx and hx and you're asked to differentiate it. Then what you do is take any function, differentiate it and keep the other two functions intact. For example, here I'm having hx. So I'm differentiating this hx, taking its dash, h dash x basically, and keeping the other two functions intact. Then take the other function. So let's say I've taken gx. So I'll be differentiating this gx, which means g dash x, and other functions, the remaining two functions, I'll keep intact as it is. Then I'll take the third function, which is, let's say, f of x. I'll take its derivative and keep the other two functions as it is. So through this method, you can differentiate the product of more than two functions. I hope you understood this process. If four functions are there, how would you do it? Did you get that point? With that, the next will be the quotient rule. It's a very simple, again, where you are given two functions, let's say numerator upon denominator. So first of all, what you do is you raise denominator to the power 2. I hope this screen is properly visible to everyone. I'm clearly visible and audible to you all. With that, what you do is denominator times derivative of numerator minus numerator times derivative of denominator. That clearly gives you the derivative of numerator upon denominator form, or the quotient rule which you asked to apply. So this is basically a revision of entire formulae of IIT mathematics which you are going to use in your examination. Moving towards the next rule. Yes, there I have seen a lot of students cursing Newton and Leibniz for developing calculus, and they get confused specifically in this section when they are asked to differentiate implicit functions. I hope you know explicit functions and implicit functions. So in explicit functions, your x and y are segregated and you can easily differentiate. But when functions appear in this form, that they're in this implicit form, then when x and y are not differentiated, when x and y are not separated or segregated, then it becomes more difficult to differentiate these category of functions, which are called implicit functions. So there is a short trick as well. First of all, one of the methods is, of course, let's say there is a function, let's say xy plus y is equal to 1. So how do you do it? Of course, it can be an implicit or explicit. In simple language, if I wish to differentiate it, what I'll do is I'll start differentiating in both sides, and I'll get a term in dy by dx. After simplification and taking dy by dx common, I'll get the value of dy by dx in x and y, of course. But here, let's say if I wish to use the short technique, what does the short technique say? I hope you all are there listening and understanding properly. I can see a lot of students right there. So can we move ahead with that? Here, I'm talking about the differentiation of implicit function, and specifically the short technique here. So the short technique says that a function which is there in x and y both. So this is a function which is there in x and y both, which means x and y cannot be segregated. The short technique says that you take the partial derivative of that function with respect to x, take negative of it, and divide that partial derivative of that function with respect to x by partial derivative of the same function with respect to y. Do you understand the concept of partial derivative, students? Partial derivative clearly means that here, when you are differentiating this function f of x with respect to x, then the terms in y should be treated as constants. So that will be del f by del x. You take negative of it and divide it by del f by del y, and that will give you the dy by dx of an implicit function. That exactly what we have written over here. I hope you have gotten a good clarity on that front. Can I move ahead with that? Now, some trigonometric identities which are very useful and crucial in differentiation and integration. What are they? Let's have a discussion on that. Just give me a moment. I need to just give me a moment, participants. Okay, so we are going great. Okay, so I can see a lot of students on the screen. Perfect. Here. Now, next part is, we know that these are some identities which we study in trigonometry, but here, why am I asking you to study them here is that differentiation and integration use a lot of trigonometric formulae. How? Have a look at that. We know sine 2x is 2 sine x cos x. Cos 2x has multiple variants. For example, one of the variants is 2 cos square x minus 1. The other one is 1 minus 2 sine square x. And when you talk about sine 2x in terms of 10x, what you do is you divide and multiply it by cos x, and there it gets converted into 2 10x upon 1 plus 10 square x. Now, with that, we know that for cos 2x, we have this identity 1 minus 10 square x upon 1 plus 10 square x. You can get it created. And here you can remember that this upon this, so sine 2x upon cos 2x will be 10 2x. With that, you can get this created. Or it's simply 10a plus b. So 10a plus b, when b is replaced by a, you get 10 2a, which gives you 2 10a upon 1 minus 10 square a. I hope you'll remember that. The next formula will be sine 3a and cos 3a. So for sine 3x, we know this version, 3 sine x minus 4 sine cube x. The other version, which IIT JEE very fondly asks, is this one. I'll highlight this one so that you don't forget this one. This one, students. This one and this one. these two versions of sine 3x and cos 3x, you should remember, you should by heart. Which one? The first one, sine 3x, you got to remember it as 4 sine 60 minus a times the sine a times the sine 60 plus a. Why am I asking you to do it? Because here, this expression is directly asked as a question by IIT JEE. Instead of a, what they have done is, okay, there is a simple correction here. Instead of a, there should have been x. So there is a typing error here. Let me just make that correction. So here it should have been x. This should also be x. This should also be x. This should be x. This should be x. And this should also be x. So what you need to understand here is that here, in that question, what IIT JEE in mains have done it, they have replaced x by, let's say, 10 degree. So the question was 4 sine 50, sine 10, sine 70. What will be the answer? If we have cracked what is x, because when you see sine 50, it will be 60 minus 10. When you see sine 70, it will be 60 plus 10. So x was basically 10. If x was 10, this expression would be equal to sine 3x. X is 10, so it will be sine 30, and sine 30 is 1 by 2. Within seconds, you can crack the answer if you could realize how you should convert this into sine 3x. So I repeat my part very clearly. You got to remember sine 3x as this and this. I hope you wouldn't forget that. Can we move ahead from here? The next part here. For tan 3x also there is a version. What does it say? That tan 3x is written as, of course, 3 tan x minus tan cube x upon 1 minus 3 tan square x. But here there is something more crucial, which is given by tan 60 minus a times tan a times tan 60 plus a. A question based on this simple identity was asked by JEE Mains as well. What was the question? Again, let's say if a was given by 10 degree, again there is a typing error. I just need to correct this thing here. It should be x here. So this is x, and this is x. So here again, if x is replaced by 10 degree, and if you are asked the value of the expression, what is the expression here, students? The expression, let's say here is tan 60 minus 10, that is tan 50, tan 10 degree, and then tan 70 degree. So with that, we have cracked x is 10. And when x is 10, you can clearly replace tan 50 into tan 10 into tan 70 by tan 3x, which is tan 30. And with that, you can mark the correct option. That's brilliant. That's great, students. I hope you all are learning and enjoying, and you're getting a great clarity on this front. With this is something very crucial. It's like they ask it every time. They make you use this particular identity in a lot of questions. So they may look like some very simple formula or identity, but you got to have them at your fingertips. Why am I asking you to keep these identities at your fingertips? Because they are used in a lot of questions and a lot of concepts. Not just in trigonometry you'll be using it. Trigonometry is widely used in other chapters. You'll be seeing it getting used in coordinate geometry, calculus, even in algebra. So yes, remember that. So if I talk about cos a, cos 2a, cos 2 square a, something like that, all you got to do is multiply and divide it by 2 sine a. So when you multiply it by 2 sine a, you got to divide it by 2 sine a. So when you multiply it by 2 sine a cos a will become sine 2a. So sine 2a cos 2a, I'll again multiply it by 2 and divide it by 2. So with that, I'll keep getting this version, sine 2 sine theta cos theta. And with that, I'll be seeing this particular conclusion. So remember this as a result, that here, when you see cos a, cos 2a, cos 2 square a, cos 2 to the power n minus 1a, here the catch is, if you could highlight or if you could clearly see the pattern here, this is a, this is 2a, this is 2 square a. So all these angles are in GP. Second conclusion, they are in GP, and the GP has the common ratio as 2. So if that is so, you can conclude it as sine to the power sine 2a, sine 2 to the power na divided by 2 to the power n times sine a. I hope you wouldn't forget that. Can we move ahead from here? Now, going ahead with the next set of rules, yes, logarithmic differentiation, I hope it's properly visible to all the participants. I'll simply say that instead of treating this, for having this short technique, use the standard version of, differentiating functions. For example, let's say you are given something like sine x to the power x. I'm taking a very simple example just to make you understand, and you're asked to differentiate it. So instead of using that short technique, simply take logarithm on both sides, and by applying the chain rule, you can figure out the value or the derivative of y, that is dy by dx. Great, great, great. So let's move ahead with that. Let's see what do we see next. Whenever you are asked to differentiate a determinant, do you know you can differentiate a determinant as well? So let's say determinant is a function of x. All the elements, all the entries are functions of x. So you can differentiate it either row wise or column wise. How do we do it? Here, the idea is really simple, students. Let's say I'm going row wise. So first of all, I'll differentiate the first row. I'll keep the other two rows intact. Plus, I'll differentiate the second row. I'll keep the first and third row intact. Plus, I'll differentiate the third row, keeping the first and second row intact. I hope there is no confusion on that. I hope you all have understood that very clearly. With that, this same process could have been done column wise as well. So you could have simply differentiated the first column, keeping the second and third intact. Then you could have plus, you would differentiate the second column, keeping the first and third intact, plus differentiating the third column, keeping the first and second intact. Moving ahead with that, what do we see next? Yes, this is something very crucial related to functions. Let's say there you see a mapping from this set A to set B. So from set A to set B, what we are clearly seeing is set A has certain elements. Let's say it has m entries. Certain B has n elements. Let's say they are n entries. What we are clearly seeing is that now, if I talk about total number of functions, that the number of functions which are possible from A to B, then what can you say about that? I have simply used the combination, permutation and combination method. What will I say? That sir, x1 has n choices. X1 can go to either y1 or y2 or y3 or yn. So if I approach x1 and ask that how many choices do you have, x1 will come up with a response saying that I have n choices. So x1 has n choices. Since it is a function, it can be many one, which means if I approach x2 and ask it that how many choices do you have, it will again come up saying with the response that I again have n choices. I can go to either y1 or y2 or y3 or yn. So again, x2 also has n choices, which means I have n choices for x2. So n into n, there are m elements in this set A, which is the domain set. So n getting multiplied m times. So n to the power m will be the total number of functions from set to B, A to B. I hope you wouldn't forget that. With that, can we move ahead? This is something very crucial, which is related to functional definitions. Questions based on this particular concept are asked by IIT JEE. So if I could simply highlight it, do remember it. What is the funda here? Whenever you see a function defined in this format, which format here, students? The format says that if a function fulfills this particular definition, that fx into f of 1 by x is equal to fx plus f of 1 by x. If a function fulfills this definition, then without any hesitation, you can always take f of x as f of x without any confusion can be taken as 1 plus x to the power n or 1 minus x to the power n. Now you will be confused, sir, which one should we choose, 1 plus or 1 minus? For that, some data will be given in the question to eliminate one of the possibilities. So it could be either 1 plus x to the power n or 1 minus x to the power n. So with the help of the data given in the question, you could eliminate one of the possibilities. And now to figure out the value of n, some more data will be given in the question. You put those values and you can figure out the value of n as well. With that, when I move ahead, what I see is, yes, something very crucial, some very decent and standard properties related to modulus. What do we see here? Always remember, whenever you see a quadratic or something like that, or somewhere modulus getting used, we can interchange x square by mod x square as per the need of the question. And we do it often in the questions. So these are the key learnings which you got to remember, which should be there in the back of your mind while solving questions of IIT JEE mathematics. For example, look at this one. Under root over x square is always mod x. I hope you remember that. This is a simple catch where students commit a lot of errors, and IIT JEE loves falling you in this kind of traps where you take under root over x square as x. That's a problem. I hope you know that. If I could simply show you why is it wrong, you would be aware of this thing, that under root over 4, right? So we all know under root over 4 is 2. It's not plus minus 2. But under root over 4, I could have written as under root over minus 2 whole square as well. Now, by your logic, if you're saying that this square and under root can be nullified, you would be saying that this could be minus 2, which is mathematically wrong. Always remember, under root over x square is always mod x. So it should be mod of minus 2, that is 2. I hope you to remember that. With that, few more learnings you got to take care of, which is whether you take mod n number of times over a same number, so it does not make any sense. It does not make any sense. If you have taken its mod once, then no matter how many times you keep taking mod, it will give you the same number, the same positive value of that x, the absolute value of that x, the non-negative number here. So that will be same as when you take the mod of minus x, when you take the mod of x, or when you take the mod of x. It will always be same. Here, Let's say when I wish to take maximum of minus x and x. So if you are assuming that some x will be greater, then we don't know because x is basically a variable. So when you wish to take maximum of minus x and x, there you get this delusion and you are always supposed to take mod x. These definitions and these understandings come very handy when you draw graphs. There you got to be very careful. There again, this is something which you would understand by yourself. Now I'll talk about these two particular identities. They are basically inequalities. This one we study in complex numbers as well, which is known as triangle inequality. Do you remember that? So here, if I simply say that when you add two numbers and you take modulus of it, then this summation will always be less than the sum of their individual mods. Did you get my point? And I hope you are able to visualize this statement very clearly. Let's say the numbers are 2 and minus 3. So if I'm adding them and then taking their mod, so it could be either a number which is equal to their sum of their mods, because if both the numbers are having same sign, then this equality will hold true. For example, if you are having minus 2 and minus 3, then it will give you minus 5, but mod of minus 5 will be 5. So here it will be 2 plus 3, because mod of minus 2 is 2, mod of minus 3 is 3. So with that, always remember this inequality gets converted into an equality when the numbers are here having same sign. In the world of complex numbers, you can say that if they are collinear, if they are lying on a same line, then this becomes an equality. I hope you're getting these terminologies very clearly without any confusion or hesitation. And that statement, which I've just stated, is written in the next line, that this mod of x plus y is equal to mod of x plus mod of y when you have both the numbers to be either positive or negative. I hope you understood my statement. Can we move ahead from here? I hope you all are there listening and understanding. Everyone, just give me a response. All the students who are there listening, understanding and watching. I hope this is how we can proceed ahead with this discussion we are having right now. Something very crucial I'd like to highlight here. I'll simply try and make you understand this part with an example. Let's say you have a number. Please remember this particular result. Let's say you have a number x and we are told that x is greater than or equal to 3. So without any hesitation, always remember, let's say if its mod is greater than or equal to 3, then yes, it brings two conclusions, that x will be either less than or equal to minus 3 or x will be greater than or equal to 3. But let's say if there is a question where there is a variable, let's say y, and this variable y, its modulus is less than or equal to 4, let's say. In that case, we would always say that yes, for this y should always lie between minus 4 and 4. These are some very basic conclusions you got to remember. But apart from these two simple conclusions, something very standard which you got to take care of is this. That's, let's say there is a variable k, and this variable k lies between 2 and 3, let's say like this. Now, two ways are there. One of the ways is that you take the intersection of this and this. So first you solve this and then you solve this. Or the other way is that you simply follow this particular result. If you could remember, this one I'm talking about. Is it written over here? Yes. There you go. So if mod x lies between a and b, where a and b both should be positive, and of course a will be lesser than b, in that case you can say that x will be between minus b to a or a to b. So what I'm trying to make you understand is, let's say whenever somebody says that mod k is between 2 to 3, so I'll say k will lie between minus 3 to 2, minus 3 to 2 minus 2, and here you got to include minus 2 because there is an equality over 2, but there is this, I cannot see any equal sign before 3. Union, it should be from 2 to 3. I hope you would remember that. Can we move ahead from here? I hope you all are there listening, watching and understanding. With that, the next part is, yes, many times in this chapter, functions, you are asked to deal with the range of expressions. So whenever you are given an expression and you've got to figure out its range, and let's say a quadratic upon a quadratic, then how do you deal with this category of expressions? The idea is really simple here, students. First of all, treat or write this as y. Take this cross product, take this cross multiplication, and then you will see a quadratic in x getting formed. In that expression, what you'll be seeing here is that this will be given as true for all the x which are real. So if this expression is true for all the x which are real, would I not say that this quadratic, which is a quadratic in x, has a lot of other variables y as well, but here this quadratic is a quadratic in x, which is true for all the real values of x, which means this quadratic must be having real roots. So if a quadratic is having real roots, you would say that its discriminant will be greater than or equal to 0. So this quadratic which you will be seeing getting created, this will not be as complicated as you're seeing on the screen right now. This will be a very simple quadratic. This quadratic will have its discriminant greater than or equal to 0. So when you put that discriminant greater than or equal to 0, you will see a solution coming out in terms of inequality, which will give you the range of y, that y should lie between these these values, or something like that. After solving this, you can figure it out. That's good, discoverer. That's great. I'm glad that you have studied. Let's focus on it right now. I hope you got that point. You will use this particular method. From here, when I move ahead with the next part, yes, something related to odd and even functions, you got to remember it. Let's say there are two odd functions. I hope at least this part I need not explain, that whenever you take f of minus x and you see it as turning out as f of x, you say f of x is an even function. And if it comes out as negative of f of x, you say that f of x is an odd function. I hope you remember that. With that, we know few very clear things, that here, always remember that when you multiply two odd functions or two even functions, then this product will always be an even function. It's like same when you multiply two negative values or two positive values, it is always positive. Second thing, product of odd and even is always odd. So negative into positive will be negative, something like that, you can remember it. Third conclusion, every function can be expressed as a sum of an even and an odd function. How do we do that? I'll simply show you a method, a straightforward method. Let's say there is a function f of x. So when in f of x you add f of minus x, and in f of x, from f of x, let's say you subtract f of minus x. So one of these functions will be even and the other one will be odd. So this clearly, f of minus x by 2, f of minus x by 2 is cancelled. So you're left with f of x by 2, f of x by 2. That leaves you with f of x. So this part is even part and this part will be the odd part. I hope you'll remember that. With that, when I move ahead with the next part, what do we see next here? Have a look at that. The derivative of an odd function is an even function. Please remember that. So if you differentiate an odd function, you'll get an even function. Similarly, if you are differentiating an even function, you will get its derivative as odd function. I hope there is no confusion on that. With that, when I move ahead, what do we see? The only function which is both even and odd is 0. Nothing needs to be said about that. A function which is even or odd, when squared, becomes an even, because even into even or odd into odd is always even. Now, the next conclusion which we'll be seeing is, yes, periodicity. So we clearly know that trigonometric functions are periodic, but based on those trigonometric functions, periodicity of these functions should be known by you, because this kind of expressions or conclusions based on periodicity will help you in being more accurate while dealing with questions based on area under the curve. But of course, they ask you to use these concepts in functions as well, in questions based on functions as well. So first of all, of course, look at this, take a screenshot if needed. But what I'm trying to make you understand is, let's say sin x, cos x, sec x and cosec x, they are raised to a certain power. The power should be either even or odd. That means an integral power. So here, if the power is even, their period will always remain pi. But if the power is odd, the period will remain 2 pi only, the original period of sin x, cos x, sec x and cos x. But here, with 10x and cot x, you got to remember, when you raise them to a certain power n, whether n is even or odd, basically n should be a natural number. In that case, the period will remain pi only. Next conclusion, when you put a mod over all these trigonometric functions, sin x, cos x, tan x, sec x, cosec x, cot x, then when you put a mod over them, the period automatically becomes pi, because the part of the graph which is lying below the x-axis comes above the x-axis. So in that case, all the functions become periodic with the period pi. The next part is algebraic functions. They are clearly not periodic. This x minus gi of x, we know this is a fraction part of x, and fraction part of x is a periodic function with period 1. I hope you can visualize these graphs which I'm asking you to memorize. So here, f of x is equal to constant is also a periodic function, but it is having no fundamental period. Now, there is something more crucial related to periodicity of functions. Let's say you're given a periodic function and that periodic function is multiplied by a scalar or a constant quantity, then its periodicity will not be affected. Its period will still remain same. But if I add a constant to this variable, let's say f of x plus c, sine x plus 3, sine x plus 2 pi, then also it will remain the same periodic function with the same period t. But what is the catch? Even if you add or subtract anything, any scalar quantity to this function, then also the period remains t. The only catch which I'm trying to give you here is that here, if to this f of x, if you are multiplying anything to this variable x, so if you add anything, if you subtract anything to this variable x or to this f of x, the period is unaffected. But when you multiply this variable by a scalar quantity, let's say k times f of cx plus d, so d wouldn't do anything, k will not do anything. The only thing which will decide the period now will be this c. So with this x, if I'm having this c as its coefficient, the new period of this function will be t upon mod c. Mind you, it's not t upon c. Usually students take it as t upon c. It is t upon mod c. Please remember that. A simple example, let's say this is the function 7 sine x, 7 sine of 2x plus pi by 9. So this wouldn't decide anything. This will not decide anything. If there is a 2 here, we know that sine x has a period 2 pi. So 2 pi needs to be divided by mod 2, which is of course 2. So 2 pi by 2 is pi. That's the period of this function. Okay. Great, Aman. Perfect. That's brilliant. Good to hear that. With that, the next part. There, in this part, students commit a lot of mistakes. What is it? Let me give you more clarity on that. Let's say there are two periodic functions and they are being added. So when you say that there are two periodic functions and they are being added, and their addition will have a period which will be the LCM of the periods of those individual functions. So let's say f1x has a period t1, f2x has a period t2. So LCM of t1 and t2 will be the period of f1x plus f2x. If h of x is not an even function, this is something you got to remember, and this is the catch where IIT JEE loves playing. But if f1x and f2x are complementary or pairwise comparable, for example, sine square x plus cos square x, that is a constant function, and that's a problem. Then in that case, you would first of all define it, you will understand it, and the other way is half of LCM of t1 comma t2. I hope we can move ahead from here. The next part is, I hope you remember that when you are asked to take the LCM of fractions, let's say there is a fraction 2 by 3 and there is a fraction, let's say 4 by, let's say any number you take 5, and you are asked to take its LCM. So how do we take the LCM of fractions, students? Do you remember that? A very basic funda I'm asking you to remember. There with fractions, you take LCMs of the numerator. So you'll be taking the LCM of 2 and 4, and you take HCF of 3 and 5. And that's how you write the LCM of these two fractions. Now, I hope you know LCM of 2 and 4 will be 4. HCF of 3 and 5 will be 1. So with that, you can say that LCM of this and this will be 4. But there is again a catch. What is that? So if you are taking the LCM of a rational and irrational number, then it does not exist. So LCM of a rational and a rational can be taken. LCM of irrational and irrational can be taken. But you cannot take the LCM of a rational and an irrational number. Please remember that. I hope you would and you wouldn't forget that. So with that, now let's talk about number of mappings. For example, here, I am asking you that let's say there is again a function f defined from a to b. So a is your domain, b is your codomain. From A to B, I am asking you to define or ensure that this is 1-1 mapping. So how do you ensure that how many 1-1 mappings can be done? So two things are there. First of all, this set A has m elements. The set B has n elements. Now, what is the condition or constraint here? So the condition is simple, that here it should be 1-1 mapping. So for 1-1 mapping, all I need to ensure is that here, when I approach this first element x1, it will come up with a response saying that I have n choices. Great. So the first element has n choices, but what about the second element? Now, since it is a 1-1 function, it cannot be many 1. So let's say x1 is mapped with y1. So x2 now has n minus 1 number of choices. It does not have those all n choices. So if x1 had n choices, x2 will have n minus 1 choices and so on. So I hope you remember, for that, basically I need to map these n elements to these m elements, which with the help of the chapter, with the concept of permutation and combination, we say NPM. I hope you remember that. But let's say, sir, the domain has lesser number of elements than the codomain set. Then can we have a 1-1 mapping? I'll say in that case, I'll have 0 number of 1-1 mapping. I hope you remember that. With that, if I move ahead with that conclusion, we see the next thing, composition of two functions. Yes, here I'm merging two concepts, composition of two functions with even and odd. Do remember these results. Let's say f is even and g is even. If both the functions are even, then their composite will be even. Second, again negative concept. If f is odd, g is odd, f of g will be odd. Please remember that. Third conclusion, if f is even, g is odd, mind you students, the order matters. If f is even, g is odd, then f of g is even. F of g means f of g. F is the outer one, g is the inner one. Vice versa is not true. What you need to understand is, if f is odd, g is even. If f is odd, g is even, in that case, f of g will be an even function. I hope you got that point very clearly without any confusion. Can we move ahead with that? I hope you all are there with me. With that, when I see the next results, there we see fundamental definitions. I hope you remember f of x into f of 1 by x. If it is given as f of x plus f of 1 by x, we treat it as 1 plus minus x to the power n, and depending on the data given to us, we conclude whether we use plus or minus or what should be the value of n. Similarly, these are some standard functional definitions which you should use directly in the questions. Questions are asked by JEE Mains where they don't define the function clearly, they give an indirect definition of it. So students use a lot of, hit and trials and then they get the result. I'll say remember these results, they'll definitely help you in cracking the definitions of the function. What do I mean by that? Whenever somebody says that f of xy is equal to f of x plus f of y, then you will say that sir, f of x is nothing but k times ln x. Or you should consider this possibility as well, f of x is equal to 0. Usually what they do in the questions is they say that there is a function f of x comma y, f of x into y, which is equal to f of x plus f of y, where f of x is not 0. So this is how they define it. So I get the clarity that I should exclude this possibility and I should continue with this. Similarly, if you are given a functional definition where you are told that f of x into y is f of x into f of y, then don't hesitate in assuming f of x as x to the power n, where n could be any real number. Third conclusion, if I am told f of x plus y is f of x into f of y, I hope you are understanding. This will be fulfilled basically when a to the power kx, something like that is there, because when the base is same and they are multiplied, the powers are added. So something like that is happening over here. So when f of x plus y is given as f of x into f of y, you should take f of x as a to the power kx. I hope there is no confusion on that. From here, f of x plus y is equals to f of x is equal to f of y. Then it will be true only when f of x is a constant function. Do remember that. Third conclusion from here, f of x takes rational values for all x, then f of x is a constant function. I repeat, we are told that there is a function f of x which takes rational values for all x. So there will be rational, irrational, rational, irrational, all sorts of numbers. But despite that, it is taking only the rational numbers. That will be possible only when f of x is a constant function. With that, the next set of rules will be, yes, transformation of graphs. Let's very quickly learn through these illustrations. For example, here I am seeing e to the power x. Right. With this e to the power x, if to f of x I'm adding 1, so the graph is shifted 1 unit above. If from f of x 1 is subtracted, the graph is shifted 1 unit below along the y-axis. I hope you got that. The next conclusion will be, let's say this is the graph of mod of x. So from x, let's say I'm subtracting a value, a positive value. Let's say 2 is subtracted. So the graph will be shifted 2 units on the right hand side along the x-axis. Let's say had it been x plus 2, had I added 2 to it. So mod of x plus 2 is there inside this entire mod. So previously I was adding a value to this entire function. This time I'm adding or subtracting a value to this x. So if that is something like that happens, and if something is subtracted, you shift right hand side, and if something is added, you shift on the leftward side. I hope you all are there listening and understanding. Everyone, all the students who are still online, understanding it. I hope we can go ahead with this space. You are able to revise everything very clearly. This one, there. You should be very careful. Let's say the graph of sin x, we all know, has its range from -1 to 1. But let's say I multiply sin x by 2. Then what happens? Then its range gets stretched. This function gets extended. So previously, if it was from -1 to 1, now it will be from -2 to 2. But still, the points where it is intersecting the x-axis will remain same. All the students who are watching it online, are you all there? Are you understanding this very clearly? I hope we can go ahead with this space. With that, the next conclusion is this, that here, let's say here, what have I done? I think this could be the graph of sin x by 2. This is sin 2x only, okay? This has gotten repeated. Now this particular part. Give me a response quickly, students. Are you all there? So with that, let's say I'm given a function f of x. I'm given a function f of x and I'm asked to draw the graph of f of minus x. So what will I do? Just take the mirror image of f of x in the y-axis. So this is the y-axis. This is your function f of x. So you take its mirror image and there you are able to draw the graph of minus of f of x. Sorry, f of minus x. I hope you got that. Minus of f of x will be a different function. F of minus x will be a different function. I hope you got that. With that, when I move ahead, what do we see next? I hope you can see the next is there when we draw the graph of minus of f of x, which I just stated. So let's say when you have this function, this is the graph of log x. So this is your function log x. And now I'm interested in drawing the graph of minus of log of x. What will I do? I'll take the mirror image of this function with respect to the x-axis. So when you take the mirror image of this function with respect to the x-axis, you draw the graph of minus of log of x. Why are we studying all these? Transformation of graphs play a very crucial role in the application of derivatives. Maxima, minima, and a lot of conclusions can be drawn while solving questions based on number of solutions, because when you are given two expressions, f of x is equals to g of x, then you draw graph of f of x, then you draw graph of g of x, and the number of points where f of x and g of x are intersecting, we say that will be the number of solutions. Or the third conclusion is that in area under the curve, you are supposed to draw the graphs. So there also, transformation of graphs play a very vital role in where it helps you in it enables you that you should be able to draw it correctly so that you get the correct answer. I hope you remember it's very important that you draw the graph correctly or accurately so that you figure out the points correctly and you could find out the accurate value there. With that, the next conclusion will be simple. Yes, this is something very interesting. Let's say I'm drawing the graph of mod of f of x. So I'm given the graph of f of x. So this is how, let's say, the graph of f of x looks like. And I need to put a mod over f of x. Now, how do we draw the graph of it? Simple, very simple. All you got to do is the part of f of x which is there on the negative side of x-axis, remove that. The part of f of x which is on the negative side of f of x, remove that. And just keep this part which is on the right hand side of the y-axis, which is there on the positive side of the x-axis. And along the y-axis, sorry, I'm really sorry. This is mod of f of x. That was f of mod of x. I'm really sorry. I confused you. I repeat my part. We are now drawing the graph of mod of f of x. We'll discuss f of mod of x as well. Forget that for a while. I repeat my part. Forget whatever I've said so far in this slide. So we are drawing mod of f of x, right? So for mod of f of x, what you got to do is simply do nothing. But here, since we are putting mod over f of x, so now f of x will become non-negative. So in this zone, whatever values are there, which are numerically negative, will become numerically positive. So this part will get reflected here and this part will get reflected here. So I repeat my part. What you got to do is, forget my word which I have said previously. You will remove this part and this part which is there below the x-axis, which is there on the negative side of the y-axis for mod of f of x. And what you do is you take their mirror images in the x-axis. So you take its mirror image in the x-axis, you take this part's mirror image in the x-axis because they were below the x-axis, they were negative. But for mod of f of x, they'll become non-negative. So with that, when this part is reflected, it becomes this, that part becomes that, and that is the graph of mod of f of x. Can I move ahead with that? I hope you all are there learning, enjoying and understanding everything, and we can go ahead with this space at this stage right before your examination. We are revising all the formulae of IIT JEE mathematics in this one single session. The next part is y is equals to log of x is given, and then I'm asked to draw the graph of y is equals to log of mod of x. Now we'll do what I was saying previously. So for log of mod of x, now x, before x I have put a mod. So all the values of x or all the negative values of x will give me the same value of log of mod of x, because x has become positive now. So for the positive values of x, I was getting all these values on the y-axis. So for the negative values of x also, I'll be getting the same values of log of x, because x, before x, I have put a mod over there. Great, students. So keep responding so that I, keep understanding that yes, you all are there listening and watching and understanding, so that we can continue at this pace. Great, perfect. So I hope you understood. For f of mod of x, if you wish to draw its graph, all you got to do is take the mirror image of this curve in the y-axis. Let's say some part of the graph exists here on the negative side of x-axis, then remove that first and then take the mirror image of the graph which is there on the positive side of x-axis on the negative side of the x-axis. Can we go ahead with that? Move ahead with that. The next part is this. Yes, now we are moving towards limit. So this is L'Hopital rule. There was a German mathematician or French mathematician, I must say, he developed this rule. So first of all, let's say you are given an expression f of x upon g of x, and it is either a 0 by 0 or infinity by infinity form. There, what you can do is, if it is a 0 by or infinity by infinity form, you can differentiate the numerator and you can differentiate the denominator separately, and you can put the limits. If it still gives you a 0 by 0 or infinity by infinity form, then again you differentiate it, the numerator separately and the denominator separately, and then you put the limits. So that's how you figure out the questions based on limits if they are giving you a 0 by 0 or infinity by infinity form. There you got to understand that not always you are supposed to apply L'Hopital rule. L'Hopital rule is definitely a good tool, but in a longer run, it becomes, in a lot of questions, ITJ knows it, that students will be prone to use it. At a lot of places, it becomes a lengthy process. So there we advise all the faculties of mathematics, they do advise that you should remember the expansions. You should remember the different techniques, for example, rationalization, factorization. You should remember Taylor series and all, so that you could work out the limits based questions with more ease. Don't solely or completely rely on L'Hopital rule. Please remember that. But yes, you should remember it. This is also used at a lot of places. Newton-Leibniz formula where you use when you are asked to differentiate a definite integration. Questions are asked based on limits. So there they are asking you to use L'Hopital rule. How will see and learn that? Don't worry about that. With that, these are some general standard expansions which I will ask you to remember. The first one being e to the power x, which is 1 plus x upon 1 factorial plus x square upon 2 factorial. This you use in binomial, this you use in calculus, this you use at a lot of places. This will be using at a lot of places. So I'm requesting you that you should remember them. You should memorize them. These expansions should be there with you. They are used at a lot of places. Please remember them. But instead of e to the power x, if it is a, any arbitrary constant, for that e to the power x, the expansion becomes 1 plus x into log a upon 1 factorial plus log a whole square into x square upon 2 factorial, and so on until infinity. I hope you all are there listening and understanding. With that, we know this is basically a binomial expansion, 1 plus x to the power n. Log 1 plus x. See, in the examination, you would not see log 1 plus x, but you may see something like log 1 plus x square. So let's say I wish to solve it with the help of expansion. So log 1 plus x square, wish to simplify. How will I do it? Instead of all those x which I know in the expansion of log x, I'll replace those x by x square. And through that, I'll be finding these values. Similarly, this one, this is something you got to remember. This is what you study in quadratic equations as well. X to the power n minus a to the power n can be expanded as x minus a whole times this. X minus a will always divide x to the power n minus a to the power n, whether n is odd or even. Do remember this conclusion. So I hope you'll run that. This conclusion, 1 plus x raised to the power 1 by x. Got to take care of this as well. The next expansions out of these, if I could ask you to remember at least 3, they'd be sin x, cos x, tan x, and one more. If I could add 2 more, then it will be sin inverse x, tan inverse x. Please remember them. These 5 ones at least you got to remember them. How I personally remember it, I know that sin x is an odd function. So for sin x, there will be odd powers. We know cos x is an even function. So for cos, we'll use the even powers. This is how I usually remember it. Again, for 10x, there will be odd powers, but the coefficients are not in that same pattern. Here, the coefficients are very standard. The coefficients are very decent. But here, in the expansion of 10x, the coefficients vary. up to this stage, at least you should have the formula of expansion of 10x at your fingertips, because in the questions based on limits, they ask you the values of arbitrary constants, let's say a, b and c, and there with expansion only you could be able to figure it out. Please remember, these are standard expansions. If you wish to take these screenshots of these slides, don't hesitate in doing that so that you could revise them after the session. There are some standard formulae based on limits. First one will be this: x to the power n minus a to the power n upon x minus a is always na to the power n minus 1. This you could prove from here only, from this expansion only, which we have just learnt. If you simply replace x by a, this will become na times na to the power n minus 1. The same expansion, the same version. Can I move ahead from here? The next set of standard limits, which are very widely and vividly used, are these. Don't forget them. Have them at your fingertips. All we are expecting is, since you are preparing for IIT JEE, so far you must have used them clearly, but there are certain catches which I'd like to highlight here. That we all know sin x upon x should be 1, but here x should be in radians. 10x upon x is also 1, because when x is so small that when it approaches 0, these limits return or results in 1. Sin inverse x upon x is also 1, they become same. Tan inverse x upon x is also 1. So these 4, I hope you are very well versed with. Few more. When it says sin x degree upon x, so what you got to understand is, in the numerator we have x degree, in the denominator we have x radian. If no unit is defined, we say that this angle would be in radians, right? So with that, we got to convert this into degrees or this into radians, whatever you wish to do it. So with that, this extra part comes into picture. I hope that arrangement is very well understood by you all. X when approaches 0, cos x is 1. I need not explain this part. Let's say instead of x, let's say sin x minus a is given. And if x is approaching a, this will be approaching 0. So this is again sin 0 upon 0. With that, you approach 1. Same holds true for this 10 formula as well. The next is log 1 plus x upon x. What you got to remember is that instead of this x, let's say they could write here an f of x. So here also I need that f of x. And let's say when x approaches a certain value a, that f of x approaches 0 and this f of x also approaches 0. So this becomes of which form? This becomes a form log 1 plus 0 upon 0. This 0 and this 0 should be same 0. I hope you're understanding my language. So with that, this also approaches 1. Are we clear on that? Can I move ahead with that? The second is e to the power x minus 1 upon x. There also this conclusion remains true. I'll write it more specifically. Let's say instead of x, instead of this x, let's say they give you f of x. Instead of this x also they give you f of x. And let's say x is approaching a. So when x is approaching a, this f of x is approaching, this f of x is approaching 0, this f of x is also approaching 0. So this has again gotten converted into the same form. Salesh is saying e to the power x minus 1. Yes, e to the power x minus 1, right? What were you suggesting? Are you suggesting a solution or a correction? So with that, e to the power x minus 1 upon x. I hope you got that point. So this is e to the power 0 minus 1 upon 0. So that instead of x, it could be any other, function or expression as well. But that expression should be same and same here. And it should approach 0 when x approaches a certain value. In that case also, you wouldn't hesitate in replacing or substituting it by 1. Similarly here, when you talk about this, a to the power x minus 1 upon x, there, it is not e, it is an arbitrary constant. Still, this holds true that it will be ln a, log a at base e. Can we move ahead from here? The next part will be some more standard results, which are very widely, very popularly, at a lot of places they are used. Which one? Let's begin with this one. Let's say f of x and g of x are two functions. And when x approaches a, they approach 0. What do I mean by that? Let's say I'm given an expression. I am given an expression where we are given 1 plus f of x whole raised to the power 1 by gx. So we can clearly see that fx was approaching 0, gx was also approaching 0. So this base is approaching 1 because 1 plus 0, and this power is approaching 1 by 0, that is infinity. So this is what? This is a 1 to the power infinity form. So to deal with 1 to the power infinity form, one of the ways is take logarithm and then solve. Or there is a short technique. The short technique says that the answer will be, or the answer can directly be written as e to the power 1 plus f of x minus 1, that is basically f of x, into 1 by g of x. So the answer will be e to the power limit x approaches a f of x upon g of x. Please do remember that. Don't forget this standard result. It is very widely used at a lot of places. When I move ahead with the next conclusion, what do we see? This is the extension of this formula only, but in a different format. And these are also the standard results created with this short technique only. Which standard results, students? Here, 1 plus x to the power 1 by x. If x is approaching 0, then this result will give you e here. Did you get my point? Similarly, instead of x, let's say I replace it by 1 by t. So this will become t. So this is 1 plus 1 by t to the power t when t is approaching infinity. So this is same as this only. I hope you're realizing it. So this is again 1 to the power infinity form. So by using this only, I can conclude that this will be e. Remember these formulae. I hope you didn't forget them. Can we move ahead with that? The next is, yes, something very crucial. Their students commit a lot of errors, and I wish to highlight this particular result so that you don't forget this result. The result is simple. The result is very straightforward. What is the result saying to you? The result says that sin x upon x, when x approaches 0, we all know is 1. But it approaches 1 from the left hand side. So it takes values like 0.0998, 0.999, something like that. It approaches 1 from left hand side. It takes all the values which are very close to 1, but from the left hand side. So with that, when you say GIF of sin x upon x is needed to be done, when x approaching 0, so you don't say 1, you say 0. Something very crucial you should remember. I hope you wouldn't forget that. Please remember this. This is a very important result. Similarly, when you talk about 10x upon x, so 10x upon x approaches 1 from the right hand side. Right hand side means it takes values like 1.00001, 1.00002. So it takes all the values approaching towards 1, but from the right hand side of 1. So the catch is when you take limit x approaches 0, GIF of 10x upon x, in that case, it will be GIF of 1 point something, which is 1. Any confusions on that? I hope you are getting it very clearly. We can move ahead with that. So there comes to the next conclusion, Newton-Leibniz formula, one of the most amazing discoveries, or what I say invention made by Newton and Leibniz both. So yes, Newton and Leibniz were two mathematicians. They were developing maths. So Newton was, I think, English mathematician. Leibniz was German mathematician, I think so. So they were developing, they coexisted basically, and they developed calculus independently. Newton in his own world, Leibniz in his own world. But the best part was that whatever conclusions they came up with were same. And that's where we, we give tribute or credit to a lot of theorems and inventions as Newton-Leibniz formula, like that. So both of them are credited with these inventions or discoveries. Here, when you talk about, let's say a definite integration is there. So a function in t is there, it needs to be integrated with respect to t, and the limits are phi x and psi x, lower limit and upper limit. So this basically, or ultimately, after definite integration and the limits are put, it will become a function in x because they are the variables in x, the limits. So it will become a function as nx, let's say ix. Now there you see a question where you are supposed to differentiate I of x. So what they developed is that you need not first of all integrate it and then find its derivative. No, please don't do that. What they suggested was that yes, there you can directly find the answer. That means the derivative of I of x is given by, through Newton-Leibniz formula, derivative of psi x, that is psi dash x, into f of psi of x, put this upper limit into this, minus derivative of phi x into f of phi of x. So instead of this t, put this phi x. How many of you were aware of it? Do tell me in the comment box so that I also get more clarity that yes, you all are there watching it very clearly. Can we move ahead from here? The next part is even more interesting. What do we see here? Yes, the limit as a sum formula. So in limits, in summation based questions, in two things, sequence and series, second limits, and third definite integration. 3 chapters are there where this particular expression is used. You can call it wherever you are using it, but it is used at these 3 chapters. How do we apply it? First, let's learn it, that what kind of expression will be visible to you and how should you convert that result. So first of all, you'll be given an expression in f of r by n. So a summation will be there where you can generalize it as a function in R and N, where you will be seeing that n is approaching infinity. So infinite terms in summation will be there. Summation means summation, addition, end. The R will be starting with the lowest possible value to a largest possible value. I'm denoting them by, let's say, phi x and psi x. I hope there is no confusion on that. With that, what you got to remember is that first of all, you remove or substitute this summation sign or sigma sign with integration. This 1 by n by d of x, r by n by x, which means this will become f of x. Now, how to find the lower limit and the upper limit? To find the lower limit in r by n, put phi x in place of r. So phi x upon n when n is approaching infinity will be the lower limit. In r by n, replace r by psi x. So psi x upon n when n approaches infinity will be the upper limit. So that's how you find the lower limit and upper limit. I hope everyone is listening and understanding, and you're understanding how are we using these results. Some theorems are there based on continuity and differentiability. Let's have a discussion on that as well. So when you say sum, difference, product and quotient of two continuous functions, then it is always continuous, given that in quotient the denominator should not be 0. Second theorem, if fx is continuous and gx is discontinuous, then nothing can be said about the product there. I repeat, if fx is a continuous, gx is discontinuous function, then you wouldn't say that fx into gx will be a discontinuous function. We cannot say, we got to work it out. Similarly, let's say fx is a discontinuous function, gs is also a discontinuous function. What about their product? Will it be a discontinuous function? No, I cannot say. I got to figure it out. I hope you understood my statement very clearly. With that, when I move ahead with the next conclusion here, fx is a differentiable function at a. This is something which IIT uses a lot many times. It is very subtly given in the questions. A lot of students solve the entire question and then they reach to the conclusion. But if you know this particular one, if you know this particular concept, you can solve the questions within seconds. What is this formula? Please understand few key things I'll be highlighting here. First of all, f of x should be a differentiable function at a. Okay. The second observation you should make is that f of a should be 0. F of a should be 0. The third conclusion you should be making is that g of x should be a continuous function at a. Three things. G of x is a differentiable function at a. Sorry, f of x is a differentiable function at a. F of a is 0 and g of x is a continuous function a. Then the product function f of x into gx will be differentiable at a. Did you understand my statement? Let's say gx is a function which is a discontinuous function. Fx is a continuous function. So far we have concluded that continuous into discontinuous could be anything. Continuous or discontinuous, we need to figure it out. But in this specific case, if you see that f of a is becoming 0, if f of a is becoming 0, then you wouldn't hesitate in saying that, sir, f of x into gx will be a differentiable function at x is equal to a. Are we clear on that? Can we move ahead from here? The next part we see is, yes, differentiability. In differentiability, you got to remember that differentiation is such a good concept that it helps you in figuring out the approximate values. What does it mean? Let's say I need to figure out the approximate value of under root 101. Let's say that's the question. I need to figure out the closest possible value of under root 101. So with the help of derivatives, you can do that. How? Let's look at that. So with under root 101, let's say I take a function under root x. So its derivative will be 1 by 2 root x. So the concept of approximation says that here, if I take x as 100 and del x as 1, so remember that this result always holds true. This is the approximate value or approximation of this expression, that fx plus del x minus fx is always f dash x into del x. What does it mean? It means fx plus del x will be under root 101 because 100 plus 1 minus fx, that is under root 100, which we know how to figure out, dot f dash x. What is f dash x? F dash x. So x will be replaced by 100. So that I know. Into del x. What is del x? Del x was 1. I hope you remember. 1 plus 100. So del x was 1. With that, under root 101 minus 100. Fx plus del x minus f of x will be this into this. This we can figure out by putting the values there. And ultimately, you reach to the conclusion with some simple calculation is 10.05. This is the approximate value of under root 101. So when approximation comes into picture, this is how you do the calculations. Are we clear on that? Can we move ahead from here? Then, what do we see next? Are you all there, students? Just give me a quick response. Although the concept of tangent and normal is removed from your syllabus, but I'm very sure IIT will ask questions based on it because it is not removed from coordinate geometry. So you may see questions. You will definitely see questions from tangent and normal. So first of all, what is the geometrical meaning of derivative? Yes, we all know that if there is a curve and if there is a point on the curve as x1 comma y1, and if I'm differentiating the curve, then the tangent drawn to that curve at that point x1 comma y1 will have its slope given by dy by dx at x1 comma y1. So in the derivative of that function, if x and y are replaced by x1 comma y1, then what do we get? We get the slope of the tangent drawn to the curve at that point x1 comma y1. So how do we find the normal to the, slope to the normal? Of course, it's very simple because we know tangent and normal are perpendicular to each other. So the slope of the tangent is m. The slope of the normal will be negative reciprocal of m, which is minus 1 by m. So if slope of the tangent is dy by dx at x1 comma y1, the slope of the normal will be dx by dy with the negative sign, minus dx by dy basically at x1 comma y1. I hope you are very much comfortable with that. And once you crack the slope of the normal or tangent or of a straight line, and if you know a point lying on it, will you not be able to write the equation of it? Which means you could write the equation of tangent and normal with such simple calculation. Everyone with me so far? Are you all listening, watching, and understanding? Can we move ahead with that? Yes. This is something I want you all to understand and pay attention to because this is that short trick through which you can write the tangent to any second degree curve. Second degree means circle, parabola, ellipse, hyperbola as of now. So what happens here in this case is, let's say we are given a curve. Second degree curve, let's say x square, ax square plus 2hxy plus by square plus 2gx plus 2ay plus c is equal to 0. So it could represent either a pair of straight lines or circle or parabola or ellipse or hyperbola. That depends. We'll discuss it in the later part of this video. But what you need to remember and understand here is that if a point lies on this curve, I repeat, that's the catch. So if there is a point x1 comma y1 lying on the curve, so this is true only for that constraint that the point must lie on the curve. If the point lies outside the curve, then this method is not valid. So if a point lies on the curve, then all you got to do is replace x square by xx1, y square by yy1, x by x plus x1 by 2, y by y plus y1 by 2. And if you see a term in xy, replace that by xy1 plus x1 by 2. Once you have made these changes, you'll see a linear equation in x and y, which would mean the tangent to that curve at that point x1 comma y1. So you need not differentiation. You need not find that, equation slope first and then write the equation of the tangent. You by simply these replacements, x square by xx1, y square by yy1, x by x plus x1 by 2, y by y plus y1 by 2, and xy by xy1 plus yx1 by 2. If you make these replacements, you will see the equation of the tangent. Isn't it interesting? So yes, you got to remember that. This is something such a crucial and important idea which you must not forget. I hope you are there listening, watching and understanding. So far we have done this much part. Let's move towards the next part here. How do you find the angle between two curves? So let's take a 5 minutes break. We'll resume in 5 minutes. I think we are going great. The screen is properly visible to all the participants. So we'll resume in 5 minutes. We are just taking a 5 minutes break. It is 13. It is 1:10. So we'll resume at 1:15. Right, students? So we'll resume in 5 minutes. Let's take a 5 minutes break. By the time you can also take a break, stretch yourself, have some water, and then we'll resume in 5 minutes. So hello everyone. Come back. I hope you all are there. Everyone, just give me a quick response. Are you all there? Hello everyone. Hello. Come back. Let's get started. Let's resume our session. So, where were we? We were discussing basically or talking about these concepts, right? So I think we now need to discuss how to find the angle between tangents. Idea is really simple here, students. Can you help me with how to find angle between tangents? I'll simply say this conclusion that here all you got to take care of is one thing. Let's say these are the two curves. They are intersecting at one point. So first of all, by solving those two curves, you find the point of intersection. Now what you do next is, come back everyone. Hello, can you hear my voice? Great. So what do you do next is, what you simply do is, you got to, let's say these are the two curves. They are intersecting at 1 point, right? Now what are we doing here is that, of course, this is the common tangent. Give me a moment everyone. Let me remove this part. This is the concept of common tangent. What are we discussing here is that let's say there are two curves. That is a different concept. This concept says that let's say there are two curves and they have, I'm basically asking you to find out the angle of intersection of these curves. Now, what do you mean by angle of intersection of these two curves? Let's understand this particular first. Okay, so we'll talk about that part later, student who is wisdom cat. But right now, all I simply want you to understand is, let's say this is the curve and this is a different curve. Let's say this is how they are intersecting. They're intersecting at this one point. So at this point of intersection, I can draw a tangent to this curve like this, and I can draw a tangent to this curve like this. So at their point of intersection, if you are drawing tangents to the curves at that point of intersection, then the angle between those tangents gives you the angle between the curves. So when somebody says you need to find out the angle between these two curves, that is what it means. So I hope you all understand it very clearly that here, this will be dy by dx of the first curve at this point. This will be the dy by dx of the second curve at that point, which means by dy by dx, I can find the slope of this line. By dy by dx of this curve, I can find the slope of this line. And once you have cracked the slopes of these two lines, would you not say that, sir, m1 minus m2 upon 1 plus m1 m2 gives you the angle between two straight lines? So this is that formula only. Can we move ahead from here? With that, the next part will be understanding the concept of maxima, minima, inflection, concave up, concave down, everything from this graph. Let's have a clarity on that. Let's say this is how the graph is going. So let us notice this particular zone. Look at this portion. In this portion, the function is increasing. The function is strictly increasing. So you see the tangents which I am drawing are clearly making acute angle with the positive x-axis, which means tan theta will be positive. I hope you remember between 0 to 90, tan theta is positive. So for those acute angles, tan theta means what? F dash x, the dy by dx. So dy by dx will be positive. So if the function is increasing, you will see its dy by dx to be turning out to be positive. Second part. If the function is decreasing and if you draw any tangent at any point, that will be making an obtuse angle with the positive x-axis, which means theta will be from pi by 2 to pi, which means tan theta will be negative. And if tan theta is negative, we know that for that dy by dx, that is f dash x, will be negative. So when the function decreases, you see f dash x to be negative. So if previously it was increasing then decreasing, which means f dash x was positive, then it is f dash x which is negative. So at this point where it has attained its maxima, increasing then decreasing, so it attained its maxima, at that point f dash x will be 0. So at these points where you are seeing f dash x to be 0 could be your critical points, and there you will be seeing local minima and local maxima and global maxima and global minima. So with that, let's say here this was increasing then decreasing, so clearly this was a local minima. But at this point, the derivative of this function is not defined, despite that it was a local maxima. I hope you got that, because in its neighborhood, it is maximum. It is attaining a maximum value. So with all that thing in mind, that when you conclude that when fx increases then decreases, then you see local maxima. And if fx decreases then increases, then you see local minima. I hope you understood that. And among all these critical points, the value of the function. So among all these points, this, you will see whichever is the highest will be the global maxima and whichever is the least will be the global minima. including the value of the function at these extremes as well. I hope you have understood so far whatever I have explained. Second conclusion is very simple here, students. I hope there is no confusion on that. With the help of second derivative, you make comment on the concavity of a function. So if it is concave down and if it is concave up, that conclusion about the curvature of a graph is brought by second derivative of the function. So if the second derivative of the function is negative, the graph of the curve is concave down. If the second derivative is positive, the graph of the curve will be concave up. And what about its increasing and decreasing nature? That nature is predicted by f dash x. So if f dash x is positive, we can say it is increasing, and if f dash x is negative, it will be decreasing. We do the second derivative test as well, the nth derivative test, to figure out the local maxima, local minima, global maxima, global minima. Through that also you give a lot of conclusions. Few more important points you should be aware of, out of which is this. If f of x is strictly increasing, then you should remember that f inverse x will also be strictly increasing. Which means if f of x is strictly decreasing, then f inverse x will also be strictly decreasing. So monotonicity remains same for fx and f inverse x. You wouldn't forget that, I believe so. Second, fx and gx have the same monotonicity if either both are increasing or both are decreasing. In that case, the composition of f of g of x will be monotonically increasing, either f of g of x or g of x. Remember, please remember, I repeat my words. If fx and gx both are either increasing or decreasing, both should be either increasing or decreasing. In that case, you will say f of g of x or g of f of x, both are increasing. Did you get my point? Here, one catches this, that if f of g of x and g of x are having opposite monotonicity, which means if fx is increasing but gx is decreasing, or vice versa, if fx is decreasing and gx is increasing, in that case, the composition, that is f of g of x and g of f of x, are strictly decreasing. Are you understanding my language very clearly? So it's same, both plus, both minus, then it is plus. If one is plus and one is minus, then it is minus. That is how you can remember these. I hope you're getting my language very clearly. The same was something like that only with even and odd functions as well, even with their composition as well. With that, yes, this is what we have already discussed. The inverse of a continuous function is continuous. Please remember that. Now, nth derivative test. A very simple example is there, that let's say I'm given a function f of x and I need to figure out its local maxima, global minima, global maxima, and all of that. So how do we do it? First of all, we find f dash x. We put it equal to 0 so that we can get the idea about the critical points. So by putting f dash x is equal to 0, I get the idea about the critical points. With that, what we see is that now I find f double dash x, and in f double dash x, instead of x, in place of x, I place all those values of x which we have attained by putting f dash x is equal to 0. With that, what we see is some possibilities. First one, f double dash a. If f double dash a, what is happening to this? If f double dash a is negative, we say that at a, it will be having a local maxima. If f double dash a is found to be positive, we say that f of x will be having a local minima, opposite. Remember, if it is negative, maxima. If it is positive, minima. Remember that. Third conclusion, if f of double dash a also turns out to be 0, in that case, can we say something about this? At this stage, no, but for that, you go for the next derivative test, which means you find out f triple dash x and then you find f of x, f triple dash x at a. And then again, by following this conclusion, you conclude. I hope you understood that statement. Now, as we have just discussed, concavity based conclusions can be brought with the help of second derivative, as we have simply discussed in the last slide. Moving ahead with the next part, yes, concept of global maxima, global minimum, we have just discussed. Let's say C1, C2, C3 and Cn, along with the boundaries where the function is needed to be checked, let's say between A to B. So I'll find the values fa, f of C1, f of C2, f of C3 until f of B. The critical points are C1, C2, C3. Along with this f of A and f of B, I'll find the value of the function at all these points. Among all these values, whichever is the greatest will be my global maxima, and whichever is the least will be our global minima. That's a simple concept, I believe so. Next is formulae based on integration. As we have started our discussion with the formulae based on derivatives, and I was clearly mentioning that from there only you will be seeing the formulae based on integration getting formed. So yes, there are these formulae. The best thing I can do is I can simply show you these formulae at this stage. I cannot do much about that. You all must be understanding it very clearly. These are some standard and decent formulae which you all should be aware of. Some formulae, yes, of course, you should understand would be these ones. Just give me a moment. I'll start highlighting them. From this onward, these are some which we haven't seen in differentiation. For example, this one. If you differentiate log of sin x by using chain rule, you will see cot x. So remember, the integration cot x will be log of mod of sin x. Remember this as a result. I hope you wouldn't forget that. The next is the integration, the derivative of log of cos x or log of mod of cos x is minus 10x. So remember, integration of 10x is minus of log of cos x. I hope you are understanding it. Through chain rule, you can work it out. Next is derivative of log of mod of sec x plus 10x is sec x. So remember, the integration of sec x is sec x plus, log of mod of sec x plus 10x. Other variants are also there. So when you replace sec x by 1 by cos x, this also becomes sin x upon cos x. So some more trigonometric expressions get formed with the help of trigonometric identities which you have learned. So there, a lot of variants can be there for the integration of sec x, which IIT JEE asks through his questions. But here, this standard one you should remember, so that whatever modification is needed to be done as per the requirement of the question, you would do that. But this standard version is what you got to remember. Similarly here, derivative of log of cosec x minus cot x is cosec x. So with that, you can conclude that the integration of cosec x will be this. The other ones are simply the inverse of what we have just discussed in the slide of differentiation. So I think we can continue with that. This is something you got to remember very clearly, that the way chain rule happens or takes place in differentiation, opposite of it would be there in integration as well. What I'm trying to make you understand is, let's say we know that integration of f of x is g of x. So integration of f of a plus x will be g of ax plus b. F of ax plus b, integration of f of ax plus b will be g of ax plus b divided by the coefficient of x, which is a. Will you remember that? I hope you didn't forget that. Some more. This one. We know integration of 1 by x is ln mod x. So remember, integration of 1 by x, but this is ax plus b. But we know for this also, integration will remain ln mod of ax plus b, but the coefficient of x, which is a, will divide it. Standard and decent results they are. The next conclusion, yes. Why are we discussing trigonometric identities at this stage while we are discussing integration? Because in integration, it is really tough to integrate product-based questions where multiple trigonometric functions are given as product. So what we do is we convert product into sum. And when product into sum is brought into picture, just hold on for a while. When product into sum is brought into picture, the job becomes really simple. Why am I saying this? Because there, integration can be splitted or distributed over addition and subtraction, that we know. So with that, if I'm given sine mx into cos nx, remember this, I will replace it by half of sine of m minus nx plus sine m plus nx. Got that? Second one. Remember these and by heart these and memorize these. They are used. Second one is cos mx sin nx. I repeat, either this one or this one, whichever you wish to remember, both are not needed to be learned. Either of this is fine because they are same actually. Now the third one, if both are sine mx, sin nx, there you take it as half of cos of m minus nx minus cos of m plus nx. The fourth one, if both are cos, which means cos mx into cos nx, where you say half of cos of m minus nx plus cos of m plus nx. I hope you remember, plus will give you 2 cos c cos d, if you could recall what I'm trying to say here. Minus will give you 2 sin c sin d. So I hope you are understanding 2 sin c sin d. I hope you are getting my idea very clearly, my point very clearly. So with that, these are derived. Some special integrals. I leave it up to you. I totally leave it up to you whether you wish to remember or memorize these or not. But let's say you say, sir, I am skipping the chapter integration for JEE because it is not high on ROI. A lot of inputs are required from this chapter. It does not give us that much output. Totally fine. But what if you are, instead of integration, practicing definite integration and area under the curve, and in those chapter a question requires or asks you to use this one? How will you solve that question? So if possible and if you can, then please learn these formulae. I totally understand that it is really difficult to learn these complex formulae, but you got to. And if you can, please, it's a request. So what do? This one I hope you know, 1 upon 1 plus x square. When integrated, gives you 10 inverse x. So here the only change is 1 upon x square plus a square will be 1 by 8 10 inverse x by. The second one, 1 upon x square minus a square. So instead of plus, it is minus. In that case, the only thing which will come into picture is 1 upon 2a log mod of x minus a upon x plus. They are created or derived or made or developed with the help of some substitutions. Those substitutions cannot be discussed at this stage, so I'm asking you to learn these directly, because you cannot derive these formulae in the real examination hall. You won't be having that much time. So simply try and learn them. And in the same fashion, remember these as well. Moving towards the next part, these are some more, and these are those substitutions which I was mentioning or talking about. Let's say in this formula a square plus x square, if you replace x by 8 and theta, and if you do it, you will very easily get this result. That's what I'm saying. Can we move towards the next part? The next part is some special category of integrals and how should you deal with them. For example, this one. This one is 1 upon a quadratic, or 1 upon under root over quadratic, or under root over quadratic. The idea is really simple. We know when we see a quadratic, by converting into a perfect square, I will be converting into that x square plus a square form. So I'll be having 1 upon x square plus a square. We know integration of that. I'll be converting into 1 upon under root x square plus a square. We know the integration of that. I'll be converting into under root over x square plus a square or x square minus a square. And we know formula to solve them. We have discussed the formula to solve them. So this is how you solve that category. This category. Here you are seeing a linear upon quadratic, or a linear upon under root over quadratic, or a linear into under root over quadratic. What do you do here? Again, Ganesh is saying I had completed 6 hours of your lecture. Whether that one complete lecture is enough for maths. At this stage, if nothing is done, that is definitely enough, Ganesh. And if not that, at least watch this right now so that you go through all the basics of maths. You could have a glimpse of all the formulae which you should have studied in these 2 years. Right. So here, if I continue with that, here in this part, a linear and quadratic are there, right? So what do we do here is, that linear part should be replaced by some constant into derivative of that quadratic plus a constant. Of course, by comparing, you can find the values of lambda and mu. And when you replace that, again by using substitution, you can again convert these standard results into these standard formula which we have just discussed and get the answer. The third set of integrations or integrals will be this category of integrals where this is a higher degree than this quadratic. In that case, when you see numerator has a higher degree than the denominator, then first you divide it, convert it into a quadratic or a linear, and then apply the same process which we have discussed in the previous 2 slides. This one, there I'm seeing a quadratic upon quadratic, a quadratic upon under root over quadratic, a quadratic into under root over quadratic. There again, the way we have followed the practice of the method for linear into quadratic, that formula, that approach will apply here. What do I mean by that? The quadratic which I'm seeing in the numerator should be replaced by lambda times the quadratic in the denominator plus mu times derivative of the denominator plus gamma. When you do that, you will see the answer coming within seconds if you know the formula of integration. Third will be this category of integrals, 1 upon a cos square x, b sin square x, or basically sin and cos x are given there in terms of square. The degree is 2. With that, what you do is you simply divide the numerator and denominator by cos square x. So there you will start seeing terms in 10x, but numerator will become a term in x sec square x. So 10x is replaced by t, sec square x dx becomes dt, and you will be able to solve them with the help of those special integral formulae which we have discussed. Are you all there listening, watching and understanding whatever I'm explaining in this session? Everyone. Can we move ahead with that? This category of integrals. So in the last category of integrals, what did we see? Power 2 was there. Here they are linear. So all you got to do is replace sin x by this 2 10x by 2 1 plus 10 square x by 2 and cos x by 1 minus 10 square x by 2 1 plus 10 square x by 2. Once you do that, you will see terms in 10x, basically 10 square x. When you replace 10 square x by t, sec square x dx will be visible in the numerator. With that, you'll see a quadratic expression. Quadratic, by converting into perfect square, will become something like x square plus a square or x square minus a square. You know the integration of that. And after that, substitute t, which was 10x by 2. And that will be your final answer. I'm just making you revise all these standard formulae, which you should have at your fingertips. Let's say, so the numerator and denominator both have terms in sin x and qx, which are linear. Great. In that case, what you do is the numerator, express the numerator as lambda times denominator plus mu times derivative of the denominator plus gamma. Again, replace that numerator by this expression, which you have just worked out by comparing the values, and then you'll get the answer. Of course, by some calculation. Moving ahead with the next part, the Eilert formula, the integration by parts formula. How do you deal with that version? Let's say u and v are two functions. I'll not tell you how do you prioritize them, how do you choose the first function and second function. You must have been doing it in physics and as well. But here, we all know it is given by first function, integration of second, minus integration of whole of derivative of first into integration of second. Do you remember that? There, what you need to understand is, it helps you in deriving a very, very crucial and important result, which IIT always asks a question from. This particular formula, if you look at this part, this will give you +4 marks if you pay attention to this particular part of the video. What I'm saying is, if you are given a question, and the moment you see that in that question of integration, e to the power x into something is given, and that something, if you could split into a summation of two functions where the second function is derivative of the first function, then don't hesitate in writing the answer as e to the power x times fx. The challenge which students face is splitting that function into sum of two functions where second function is derivative of first function. If you are able to do so, you will get your answer within 10 seconds. Remember this. IIT definitely and always asks questions based on that. So even if you are skipping integration, if something like this is seen by you, you should attempt it if you know the basics. Moving ahead with the next part, what do we see? F of x minus 1 by x, 1 plus 1 by x square. These are some standard substitutions I'm suggesting right now. So when you see something like that, replace x minus 1 by x by t. So if you square both these sides, you will get this result as well getting replaced. And there you will get 1 plus 1 by x square dx as dt. So it will basically become ft dt. A very simple, straightforward question. Do remember this substitution. Similarly, let's say you have a quadratic in the numerator and a biquadratic in the denominator. So what do we do then? In that case, divide the numerator and denominator by x square. When you do so, you will see an expression which can be dealt by you with the help of this category of substitutions. I hope you wouldn't forget that. Can I move ahead from here? Now, this is something very interesting. Let's say you are given sin x into cos x, but sin x and cos x are raised to a certain power. Now, depending on that power, you do certain substitutions and get the answer. What are they? Let's begin with the first one. First of all, yes, m and n should be the natural numbers. The condition is, let's say if 1 is odd, then substitute for terms of even power. So let's say one of them is odd, one of them, which means power of one of m and n, one of them is odd. So the even one, let's say sin x is having odd power, cos x is having even power. So that even power version, cos x, that you substitute by t and you will see your answer coming within seconds. Second version is, if both are odd, you can substitute either of them. If both are even, use trigonometric identities only. For example, sin square x, cos square x, something like that, and then solve it further. I hope you remember sin square x plus cos square x is 1. That kind of substitution or suggestions are recommended here. This category of integrals, just take a screenshot of it. You can revise it by yourself. This portion of this slide is self-explanatory. Now, moving ahead with this part, definite integration is what we are doing right now. Definite, then area under the curve, then differential equations, and then we'll move towards the next section, which is the algebra. Now, with that, what do we see here is fx dx. Then always remember, if the limits are a to b, I can replace x by a plus b minus x in any question of definite integration. Do you remember that? So instead of a, this is 0, and let's say this is a, which means 0 to a, then I can say that it is f of 0 plus a minus x, usually known as King's property among your fraternity. I hope you remember. With that, we know one more thing, that minus a to a f of dx is 0 whenever fx is an odd function, and it is 0 to 2. What is wrong here? I think I need to make a correction here. It should be like this, 0 to a 2 times f of x dx. Do you remember that? Similarly, these conclusions can also be drawn, which are simply extension of what we have just discussed. Few more based on periodicity. Before that, I would request you that if you could, try to learn this result. It is used in a lot of questions. So the moment you see 0 to pi by 2 log of sin x or 0 to pi by 2 log of cos x, replace it pi by 2 log 2 negative of it, minus pi by 2 log 2. It is used at a lot of places. Please remember this result. Just give me a moment. I'll be back in a minute. Green tea ka bolna. Green tea. Haan. With that, when you talk about periodicity or periodic functions, please have a look at that part. Definite integration means what? Area under the curve. So if there is a function which is from 0 to nt, fx. So nt means what? This fx is a periodic function with a period t, capital T. So that n intervals are coming into picture, that n iterations are coming into picture. So all I'll do is, I'll integrate it from 0 to t, that one cycle. And that same cycle is getting repeated n times. So I need not integrate it from 0 to nt. I'll integrate it from 0 to t, and then I'll introduce this n. Did you get that part without any confusion? From here, let's say a to a plus nt. So that again cyclicity has come into picture. So what you do is, you simply write it as 0 to nt. Let's say a plus nt to b plus nt. So this nt and nt extension will not come into picture. You can write it as a to b. Similarly, a to b plus nt. So for that, all you got to do is, first of all, take it from a to b, and then from 0 to t n times of it. These are some standard conclusions. So will there be a class like this for physics and chemistry also? I doubt, but I definitely request this particular part to Sumit sir and Gaurav sir. Don't worry about that. With that, this is a very important conclusion where you got to remember that, let's say this is a curve, and this curve has its minima or maxima. So let's say its minimum value is small m and its maximum value is capital M. Between this a and b, between this value on the x-axis, that is a and b. So between this point a and b, its minimum value is small m and maximum value is capital M. In that case, the a to b integration of f of x is given by small m times b minus a and capital M times b minus a. These are the ranges of this expression. So it will always be greater than this. It will always be less than this. Do remember this as a result. Are we clear on that? Can I move ahead from here without any confusion? So when we see the next part, there I see Wally's formula. It is known as Wally's formula, but not to scare or intimidate you, but to make you understand that it is such a crucial and important formula that within seconds you can solve a question if you know this short trick. This is of course not a trick, but people have started calling it a trick. This is a standard formula developed by Wally, the mathematician. What does this formula say? Few things. Let's say sin x into cos x. Sin x is raised to a certain power, cos x is raised to a certain power. These m and n should be natural numbers. 0 to pi by 2, the limit is 0 to pi by 2. Then there are two possibilities. Which two possibilities? If m and n both are even, if m and n both are even, let's say this m and this n, the powers of sin x and cos x both are even. In that case, what you do is m minus 1, m minus 3 until 1 or 2 is achieved. And then n minus 1, n minus 3 until 1 or 2 is achieved. Don't take it for the negative values of them. divided by m plus n, then m plus n minus 2. Keep doing it until 1 or 2 is achieved. Times pi by 2 if both are even. If that is not the case, if one of them is even or both are odd, in that case, just don't introduce that pi by 2. Keep the remaining part same. That will be the answer. Even if it may look a little difficult, just practice 2 to 3 questions, you will get the idea. And the moment you see a question like this in the real examination hall, you can solve it within 10 seconds. Please keep this with you. With that, when I move ahead with the next part, what do we see? We see some exact differential equations. For example, whenever you see, now I'm talking about differential equations. Whenever you see x dy plus y dx, you can replace it by dxy. Whenever you see x dx plus y dy, you can replace it by half dx square plus y square. Whenever you see x dy minus y dx upon x square, you can replace or substitute it by dy by dx. These are exact differential equations. Similarly, these are some more, and there are a lot many, but at least these initial 4, or at least this one, you should remember. They are used at a lot of places, and you can solve questions if you know these conversions. The next one will be vector in 3D. So far we are done with calculus. Now moving towards the next portion, vectors in 3D. Okay, so let's take another 5 minutes break. I'll just have some water and then we'll continue. 5 minutes break means it is 13:50, 1:50. So we'll resume at 1:55. Okay, so we'll start, resume means we'll start vectors in 3D at 1:55. I hope that's okay. Hello, 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 hello. I hope I'm clearly audible. So if you all can hear my voice, come back everyone. If you were out there taking a break or flexing out. So yes, let's get started or resume with vectors in 3D. If I could start my simple discussion, we all know that if a line makes positive angle, if a line makes alpha with positive x-axis, beta with positive y-axis, and gamma with positive z-axis, we know cos alpha, cos gamma, cos beta give you the direction ratios, direction cosines of this line segment OP. You remember that? So we usually denote cos alpha, cos beta, cos gamma by L, M, and N. And with that, we know that L square plus M square plus N square is always 1. Right. Along with this, yes, something more is there. If I could highlight that, if whenever you see that, if somebody says that direction cosines are there, if I take their ratios, they become direction ratios. So usually, this is not always true. If L, M, and N are direction cosines, and if I take their ratios, there will be A's to B's to C. So if we find A square plus B square plus C square to be 1, I can say that these are not simply direction ratios, but also direction cosines. Will you remember that? Along with this, I think this is all. Now moving ahead with the next part, what I see is, yes, this is something I would not be revising, or I will be, but yes, learn it in 3D only, vector only, so that you don't have to do it in 2D. Coordinate and 3D are almost same, but you got to look at the pattern. So if I say that there is a triangle ABC, its position vector of centroid is always sum of these three vertices divided by 3. But for in center, what you need to do is, for in center, opposite to this vertex A, there is a side BC, so its length is given by, let's say, BC. Opposite to this vertex B, there is a side AC, so its length is given by mod AC, or vector mod of vector AC, magnitude of vector AC. And opposite to this vertex C, there is a side which is AB. So side length BC into A, side length AC into B, side length AB into C, sum of it divided by AB plus BC plus C, that is perimeter of the triangle. That gives you the position vector of the in-center. Everyone come back if you can hear my voice. I hope you all are there listening and understanding and watching and learning a lot from this final session of mathematics before your JEE. With that, position vector of orthocenter. Remember, A has an angle which is capital A, so A times 10A, vector B times 10B, vector C times 10C upon 10A plus 10B plus 10C will give you orthocenter. Similarly, when you talk about circumcenter means the circle which you are circumscribing on this triangle, that will be sine 2A, sine 2B, B, sine 2C, C, sine 2A, sine 2B, sine 2C, sum divides it. I hope you remember it. And the same I'll be saying or suggesting or doing in 2D as well. So remember it. Let's say there are two vectors. This is vector A, this is vector B. And I need to figure out the internal angle bisector of these two vectors. So I'll find a unit vector of A, I'll find a unit vector of B, and when I join them, of course, I'll see a rhombus getting formed. With that, this will be A cap plus B cap. So any magnitude multiplied to this A cap plus B cap as per the vector law of addition, this will be the internal angle bisector. If I talk about external, this will be minus A cap, or you can call this as minus B cap. So with that, this vector here will be any magnitude times A cap minus B cap. That will be the external angle bisector. Everyone, are you all there? Moving ahead with that, the next part. Here, please understand. Let's say these are the 3 points. These are the 3 points. And they are told, we are asked to check whether they are collinear or not. So this is exactly what we'll study in 2D as well. We'll ask you to figure out the triangle formed by x1, y1, x2, y2, and x3, y3. So if the area of that triangle is 0, we say that these points are collinear. So that's exactly what we are applying here. I hope you are clearly understanding this particular part. With that, when I move ahead towards the next portion, what we see is, yes, the dot product. So this is the vector A, this is the vector B, and the angle between vector B, A and B is theta. That is always between 0 to pi, remember that. So yes, we know A dot B is a real quantity, is a real number. So it's a scalar quantity in your sense. So it will be a real number. A dot B will always be less than mod A mod B, because it could be negative as well, A dot B. And yes, if A dot B is positive, we say that the angle between them is acute. If A dot B is negative, we say that the angle between A and B is obtuse. And the dot product of a 0 and a non-zero vector is a scalar 0. Remember that. Next part, when you say that there is a vector A and there is a vector B. So if somebody asks you to figure out the projection of A on B, so this is what you mean by projection of A and B. So this length, projection of A on B, is given by A dot B divided by mod B. I hope you got that. Similarly, projection of B on A is given by B on A, projection of B on A. So mind you what, the on A. On A means mod of A will come in the denominator. The third part, angle between two vectors is, let's say angle between two vectors is theta, and the two vectors are, let's say vector A and vector B. With that, the angle, the cos theta or the angle theta is given by cos inverse of A dot B divided by mod A mod B. So that's how you figure out the angle between two vectors. Any confusions on that? The next part is in component form. How do you find the dot vector? So let's say vector A is given by A1, A2, A3. Of course, I cap, J cap, K cap are also there. Vector B is given by B1, B2, B3. So dot product will be given by multiplying their components. I mean A1 with A2, B1, A2 with B2, and A3 with B3. That's how you find the dot product in component form. So with the help of that, you can definitely figure out the angle between these two vectors. Did you get my statement? Now, here, moving ahead with that, these are some simple results which you should remember, because when you solve questions based on vectors, you square them, you subtract them, you multiply them, and these kind of expressions get formed. And how do you deal with them? That's exactly what we are discussing. So sum A plus B mod square can be written as mod A square plus mod B square plus 2 times A dot B. Similarly, these are also there. I hope you must have seen them. Some important conclusions which I would highlight here would be this, that if you see mod A plus B is equal to mod A plus mod B. Do you remember this inequality we study in complex numbers as well? So there will say that these complex numbers are parallel, collinear. Do you remember that? Here, if you see that square of mod of A plus B is equal to square of A plus square of B, which means this term has vanished. So if 2 times A dot B becomes 0, that happens only when A dot B is 0. A dot B is 0 means A is perpendicular to B. Now, moving towards the next part, whenever somebody says here A plus B is equal to A minus B in terms of mod, then also this leads you towards this conclusion only. Because if they are equal, their squares will be equal, which means this will be equal to this, which means it will be 0. Will you remember that? Now, vector dot product in the component form, as we have just discussed, this is how you write the dot product in the component form. The second conclusion is this. Here, if you multiply a vector with itself, it simply is nothing but square of its magnitude, because A1 plus A2 plus A3 that is this only. I hope you got that. With that, let's move towards the next part, the cross product. First of all, please understand, if you are asked to figure out the cross product in component form, I'll show you this part first here. So let's say these are the two vectors. One of the vectors is vector A, which is given by this A1, A2, A3. Vector B is given by B1, B2, B3. So if I'm asked to figure out A cross B, so A cross B is given by I cap, J cap, K cap in the first row. Components of first vector A, A1, A2, A3 in the second row. Components of the third vector B in the third row, B1, B2, B3. And I hope you know how to expand a determinant, and by having so, you can figure out A cross B. Everyone with me on this? Now, coming back to the discussion we were having, the way we can easily, have the dot product, we cannot have the cross product with that ease, because cross product follow certain rules. What are those rules? Cross product, first of all, is not commutative. What does it mean? A cross B is not B cross A. A cross B is negative of B cross A. So while solving vector equations, you got to take care of it. The next part is, it is not associative, which means A cross of whole of B cross C will not be same as A cross B whole of cross of C. I hope you're understanding the difference. In dot, we could do it. Even in dot, we cannot do it, because this dot product, of course, will give you a scalar quantity. Here we are multiplying vectors. Now with that, here, in dot we can, but specifically in cross, we cannot do such things. With M scalar times A cross B, here we can swap this M either with A or B or with both. I hope you are understanding it. Now the next part is, it is distributed over addition or subtraction, but you got to take care of the order, whether it is coming from left side or right hand side, which means, let's say if it is A cross of whole of B plus C, that will be A cross B plus A cross C, but A will be there on the left. If it is B plus C whole of cross A, then it will be B cross A plus C cross A. There A will be on the right. I hope you understood my statement. So this is how you remember these things. And if I could move ahead with that part, yes, we remember that if we are doing the cross product, it is mod A mod B sine theta, which means there you see the cross product turning out to be 0 if the two vectors are parallel. So if two vectors are parallel, we say I cross I, j cross j, and k cross k to be 0. With that, one more conclusion you can bring into picture, that I cross j, if I follow this right hand system, will be k, j cross k will be I, and k cross I will be j. But if I swap the order, it will become negative of it. Did you understand that? The most crucial part here is Lagrange's identity. What is it? Please have a look at that part. We know A cross B is mod A mod B sine theta. A dot B is mod A mod B cos theta. So if I square and add them up, so it is mod A square mod B square sine square theta, mod A square mod B square cos square theta. Mod A square mod B square can be taken common. So you're left with cos square theta plus sine square theta. That is 1. So it leaves you with mod A square mod B square. Remember it. That is something which IIT JEE uses and asks in a lot of questions. I hope you wouldn't forget that. From here, when I go ahead with that, this is something we have already discussed. Yes. Let's say I'm given two vectors A and B. I hope all these students are there listening, learning, and understanding everything. And I am getting a parallelogram formed with the help of vector A and vector B. So these are the two adjacent sides of a parallelogram. With that, let's say if somebody asks you to figure out the area of this parallelogram, all you need to do is take the cross product of it and take its magnitude. After cross product, you'll be seeing a vector. And when you take the magnitude of that vector, it will be the area of that parallelogram. Will you remember that? These are the applications of cross product in geometry. Second is, let's say there is a parallelogram and its diagonals are given. So parallelograms diagonals are given by d1 and d2. So again, you take the cross product of d1 and d2. It will be a vector. Take its magnitude and half it. It will again give you the area of the parallelogram. The same holds true for any quadrilateral. I repeat, for any quadrilateral. So if you see a quadrilateral which has its diagonals given by AC and BD, so you take cross product of AC with BD, it will be a vector, take its magnitude and divide it by 2, it will give you the area of any quadrilateral. Mind you, students, the area of a triangle which has adjacent sides, let's say A and B, adjacent sides. Of course, if it was a parallelogram, then it will be magnitude of A cross B. But if it is a triangle, then it will be half of A cross B, because for a parallelogram, those two equal congruent triangles will get formed. Can I move ahead with that? From here, what do we see the next part? I'll talk about 3D. This, I think I need not make you understand the distance formula. This is something which you got to understand. Let's say there is a straight line. And this straight line is divided by a plane. So try and imagine this in 3D, that there is a plane and this line is passing through this plane. So this line is intersecting this plane at a certain point. Now, we are given the equation of the plane as ax plus by plus cz plus d is equal to 0. And it is formed by joining the 2 points, let's say P and Q. So this is P and this is Q. And there, this point P is x1, y1, z1 and Q is x2, y2, z2. Then always remember, without much calculation, without getting deeper into much this part, without calculating a lot, with this short technique, with this simple formula, you can figure out the ratio in which this plane is dividing this line segment, which is created by joining these 2 points. What do I mean by that? Have a look at this part. Please understand. Let's say at this point Q, this line is intersecting this plane. So PQ, sorry, this cannot be PQ. Let's take it as R. So PR is to RQ can easily be given by, let's say lambda is to 1, and that lambda is to 1 is nothing but this ratio, which is negative of power of the point P with respect to the plane divided by power of the point Q with respect to the plane. The same formula we'll be using in the chapter straight lines as well. Remember that. So when 2 points are joined and a third point comes into picture, or a straight line comes into picture, that will also divide that line segment into a certain ratio. That same formula I'll be using there in 2D as well. I hope you would remember it. Now, we already know this particular result. I need not discuss it. Something very crucial here is this. Let's say I have 2 lines and those 2 lines are having their own direction cosines. Let's say L1, M1, M1 and L2, M2, N2. Then the angle between those 2 lines is given by modulus of cos theta is given by modulus of L1, L2 plus M1, M2 plus N1, N2. Remember that. Had they been direction ratios, I wouldn't use the same formula. In that case, the formula will change a little. In that case, let's say the direction ratios, instead of direction cosines, the direction ratios are A1, B1, C1 and A2, B2, C2 for these two lines. Then cos theta is given by same as L1, L2 plus M1, M2 plus N1, N2 divided by under root over L1 square plus M1 square plus N1 square. But for direction cosines, that will become 1. But here for direction ratios, it will stay like that. Into L2 square plus M2 square plus N2 square. I hope you didn't forget that. Can we move ahead from here? I hope you all are there. Two conclusions you got to remember from here is that if two lines are perpendicular, cos theta will be 0, which means L1, L2 plus M1, M2 plus N1, N2 will be 0. If instead of L, M, N, ABC are given, which means direction ratios are given, then also A1, A2 plus B1, B2 plus C1, C2 will be 0 if the lines are perpendicular. What if the lines are parallel? In that case, they'll be proportional, which means L1 upon L2 is equal to M1 upon M2 is equal to N1 upon N2. The same will be true for direction ratios as well, which means A1 upon A2 will be equal to B1 upon B2 will be equal to C1 upon C2. Remember that. Now comes the next part where we say that how do we write the equation of a straight line in 3D. So let's say there is a straight line and this straight line passes through a point x1, y1, z1. So a point x1, y1, z1 lies on this line. And this line is parallel to a line segment which is ai cap plus bj cap plus ck cap. Or I can say that the line is having direction ratios as ABC. So the equation of the line is given by x minus x1 upon a, y minus y1 upon b is equal to z minus z1 upon c. And if I wish to take a point lying on the line, I'll parametrically put it equal to lambda, and I can express x, y, z in terms of lambda. So x will be a lambda plus x1, y will be b lambda plus y1, and z will be c lambda plus z1. With that, you can have any point lying on the line defined parametrically. Did you understand that? I hope everyone is listening and understanding this very clearly. The next will be, let's say instead of one point in the direction ratios, I'm given 2 points through which the line passes. So of course, with x2 minus x1, y2 minus y1 and z2 minus z1, I can have the direction ratios of the line which is parallel to the given line. And since the line passes through x1, y1, z1, I can again write the equation of the line. I hope you understood that statement. With that, the next part, condition for perpendicularity. The same conclusion can be applied here. We know that if two lines are there, they'll have their direction ratios. So the direction ratios of the first line are A1, A2, A3, A1, B1, C1, let's say. The direction ratios of the second line are A2, B2, C2. So if they are perpendicular, we know A1, A2 plus B1, B2 plus C1, C2 will be 0. I hope you understood that. But if those two lines are parallel, then they'll be proportional. What will be proportional? Their direction ratios. Everyone with me so far? Can we continue from here? Now, the next part. This is one of the most crucial part. JEE definitely asks question based on it. To figure out the shortest distance between two skew lines. I hope you understand that in 3D, lines could be parallel, lines could be non-parallel, and if lines are not lying in the same plane, and if they are not intersecting, then they are called skew lines because they never meet, nor they are parallel. In that case, there is a concept of finding the shortest distance between those two lines. And we always remember that shortest distance between two curves is always found along the common normal to the curves. So here, these are the two lines. I have drawn a normal PQ, which is the common normal. There is a point lie on L1, there is a point lie on L2. And if I join L1 and L2, if a line segment gets created by joining those points on L1 and L2, if I take the projection of that line segment on the perpendiculars of these two lines, then that projection will be that shortest distance between these two lines. This is the concept you must have studied. So if I apply that simple idea, all I'll be saying simply here is this idea that here, let's say the equation of the first line is given by, let's say R is equal to A1 plus lambda B1, and the equation of the second line is given by R is equal to A2 plus mu B2, right? In that case, we know that the first line is passing through A1 and is parallel to B1. The second line is passing through A2 and is parallel to B2. I hope you're understanding. The first line is having a point A1 lying on it and it is parallel to a vector B1. The second line is having a point A2 on it and it is passing through a vector. It is parallel to a vector B2. Do you remember that discussion? So all I'm saying is the projection of A1, A2, this line segment on the normals to B1 and B2 will be the shortest distance, which is PQ in our case. So all I'm suggesting here is a very simple idea, which you are supposed to follow is box of B1, B2, A2 minus A1, scalar triple product. So B1 dot B2 cross of A2 minus A1. This A2 minus A1's projection on B1, B2, B1 cross B2 will be this. I hope you're understanding it. So this is our PQ. If I take mod of it, which means I'll get the length. So shortest distance is given by, shortest distance is always given by A1, A2 minus A1 cross B1 dot B2, or better is A1, A2 minus A1 dot B1 cross B2, because dot and cross can be swapped in box in STP, in scalar triple product. That's what I'm suggesting. Let's say I wish to use this formula in 3D. So in that case, what will I do? First line passes through x1, y1, z1. Second line passes through x2, y2, z2. So box of b1, b2, a2 minus a1 will be done by a2 minus a1, which is x2 minus x1, y2 minus y1, z2 minus z1. What is b1? The L1, which is parallel to b1, that is a1, b1, c1. b2 is a2, b2, c2. So if I take determinant of it, it will be box of b1, b2, a2 minus a1 divided by modulus of b1 cross b2. So I'll find b1 cross b2. b1 cross b2 will be determinant of I cap, j cap, k cap, a1, b1, c1, a2, b2, c2. And then after having this factor, I'll take its magnitude. That's exactly what we have done over here. Did you understand this part? Let's say it asks me to check whether these two lines intersect or not. So what will I do? If these two lines are intersecting, the distance between them, shortest distance between them will be 0. And if the shortest, I hope I'm clearly audible and visible, the streaming is going smoothly. So with that, we can say that this value will be 0. If this distance is 0, that means the numerator is 0. Everyone with me so far? Can I continue from here? Let's say the two lines are parallel. If the two lines are parallel, what does it mean? Let's say if the two lines are parallel, in that case, equations of these lines will be given by what? A1 plus lambda b, A2 plus mu b, because they are parallel, so b and b will be same. In that case, the shortest distance, shortest means what? If they are parallel, there will be only one distance, that is the distance between those two lines, is given by A2 minus A1 cross b upon mod b. Remember that. I hope this whole slide is very well understood by you all. Take a screenshot of this complete slide, because it is one of the most important concepts of vectors in 3D on which questions will be asked. Along with this, I hope you haven't forgotten that we have started our WhatsApp channel where we keep posting all our updates, whatever we are coming up with, so that if you don't want to miss anything, you can scan this QR code and you can follow our channel from where you are getting all the updates about all the happenings we are doing. So we are done with calculus, we are done with vector in 3D. Now we are moving towards the third most important section of your IIT JEE mathematics, where we are revising all the formulae of IIT JEE mathematics. Entire maths we are revising in this one session. After algebra, we'll move towards trigonometry, and then we'll end this session with coordinate geometry. Now let's focus on algebra. So in algebra, if I begin with the first chapter for the day, we know iota, complex number has come into picture. So if I could start my discussion with iota, we know that any power of iota, which is a multiple of 4, will give me 1. Any power of iota, which is 1 more than the multiple of 4, will be 1. Iota to the power 4n plus 2 will give me minus 1. And iota to the power 4n plus 3 will give me minus iota. This cyclicity we all understand. With that we know and remember, the sum of 4 consecutive powers of iota is always 0. Remember this as a property. 2 more conclusions I'm asking you to remember. 1 plus iota upon 1 minus iota and 1 minus iota upon 1 plus iota. There you remember 2 results by having their conjugate and rationalizing them. Rationalization is not the correct word, but the process remains same. Through that you can find this value as iota and this value is minus iota. Remember that. Now, the next thing is, how do you multiply complex numbers? Let's say one is a plus iota b, second is c plus iota d. So a into c, a into iota d, iota b into c, iota b into iota d. And that's how you multiply it. How do you divide? You simply divide it. Let's say a plus iota b is needed to be divided by c plus iota d. So I'll take conjugate of c plus iota d, that is c minus iota d. I'll multiply and divide it so that I'll get the value of z1 upon z2, which will be simply this, but you need not remember this result. The next result, I hope you remember, conjugate of the conjugate of a complex number is the original complex number. And if you add a complex number to its conjugate, it gives you double of its real part. If you subtract the conjugate of a complex number, it gives you the double of its imaginary part. if I add the conjugate of a complex number to itself, and if the value is found to be 0, we remember and we know that z will be a purely imaginary, and vice versa. Which means if in a question I'm told and given that z is a purely imaginary complex number, I'll say that z plus z bar will be 0. I'll use this unhesitatingly. I hope everyone is there listening and understanding and watching it very clearly. And you all are gaining a lot from this session. With that, z is told to be purely imaginary. If I'm told or given that z is a purely imaginary number, sorry, real number, then I'll say it will be equal to its conjugate because it is purely real. Next part, conjugate can be distributed. Tell the way to complete 3D geometry. Didn't touch it, but completed vectors. Great, great, great. Okay. With that, conjugate can be distributed over addition and subtraction. Not just that, it can be distributed over multiplication and division as well, like this. I hope you would not forget that. Here, remember, if two complex numbers are equal, their magnitudes and their arguments will be equal. But if the argument of a complex number is either pi by 2 or minus pi by 2, it lies on the y-axis, which means it will be purely imaginary. If the argument of a complex number is 0 or pi, that means it will be lying on the real axis, that is the x-axis, so it will be purely real complex number. Next is properties related to modulus. We have discussed it a lot many times. Let's have a look at that. We know that modulus is always non-negative, and if modulus is 0, that means complex number is 0, because that is the only possibility. Otherwise, complex number is always positive. If I am told or asked about the imaginary part and the real part of a complex number, then you can, without any hesitation, say that real part of a complex number always lies between negative of mod z to mod z, and the same can be said about the imaginary part as well. The third conclusion is a very important one. You take modulus of a complex number, or its conjugate, or its negative, or the conjugate of its negative. It will be same. Remember that. Yes, this is something which looks very small, but it is used in a lot of questions. So many times we solve complex equations based questions, and there we often replace zz bar by mod z square and vice versa. Modulus is not splitted over or distributed over addition or subtraction, but it can be splitted over multiplication or division. Students, all the students, those who are watching it online, just give me a response in the comment box. At my front, the screen is lagging. I can see a lot of fluctuation on the screen. Is it happening at your end as well? I hope I'm clearly audible and visible to all the participants. Just give me a quick confirmation. Now, the triangle inequality, which we have discussed, that here, sum or difference of two complex numbers, the magnitude of sum or difference of two complex numbers is always less than equal to the sum of their individual modes. Don't forget that. From here, one more conclusion is there, that great, thank you so much. So with that, modulus of sum or difference of two complex numbers is always greater than the difference of their individual magnitudes. So these two results are very widely used whenever you are asked the minimum or maximum value of a complex expression. So you'll be given a complex expression and then you need to find out its maximum or minimum value. So there we use these triangle inequalities. They are very useful. Your screen is not properly clear. Tanushri, can you be more specific? I didn't understand. Is it lagging behind? Is it fluctuating? Okay, Santosh is also saying the same. Let me get it fixed. Give me a moment, everyone. Just give me 2 minutes. Just give me a quick confirmation. I hope it's not lagging anymore. It's properly visible. Let me also check it once, then we'll resume. Hold on for a while, students. I hope it's not lagging anymore. Is it properly visible? I hope it's going great. All the participants, give me a quick confirmation, everyone. Are you all watching it live, everyone? All the participants? I think it is still lagging at my end. Is it lagging at your end as well? Give me a quick response. I hope my voice is audible. Great, 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 KK. I hope all the other participants give me a quick response. Is it still lagging? Okay, Tanush, so is it going fine now? Can we continue with that? Just give me a moment. Okay, Ayushi is saying it is lagging. Still lagging for Santosh. Okay. So let me get it fixed, otherwise it won't make much sense then. दिक्कत आ रही है भीम, है ना? तो देखना है ना, 5 मिनट का ब्रेक लीजिए। I hope the issue is resolved now. I am very properly visible to all the participants. Now let's resume it again. Can we continue now? Students, just give me a response. I hope it's properly visible and it's not lagging anymore. So here we are. I would say that yes, this is something related to modulus, and this is what the conclusion of the triangle inequality, which is the merger of this and this, which gives you the maximum and minimum value about the complex number. Yes, I think on my screen it is going fine. Let's continue further. This we have just discussed. This is something you can figure out the reciprocal by division property. This is something related to the argument of a complex number. What is it? Have a look at that. Argument of z1 into z2. So argument, I personally remember it like, it behaves like logarithm. You remember log mn is log m plus log n. So this is how I personally remember it. So argument of z1 z2 is argument of z1 plus argument of z2. Similarly, argument of z1 upon z2, argument of z1 minus argument of z2. Of course, we add 2k pi so that we keep ensuring that its principal value is taken. Argument of z upon z bar. So argument of z is argument of z, but minus argument of z bar. Z bar is conjugate, which means negative of argument of z. So it is 2 times argument of z. Did you get that? Here, argument of z to the bar n becomes n times argument of z. I hope you'll remember these results and you wouldn't forget them. Let's continue further. So if two complex numbers are having same arguments, which means if I treat them as vectors, or in 2D if they are collinear, then yes, we do remember the sum of these two complex numbers, and when you take mod of it, it will be equal to the sum of their individual mods. If they are in opposite directions, like if in vectors, if one is directed like this, one is directed like this, it means if they are having 180-degree angle between them, then I'll say the difference of their individual mods will be equal to their sum, the distance, the length. Now, Euler has suggested you that complex numbers can be converted into polar form and polar can be reduced as Euler form. So e to the power iota theta, Euler has given it as that it can be written as cos theta plus iota sin theta. And there we know that we can write a complex number a plus iota b as cos theta plus iota sin theta form, polar form, and that form can be converted into Euler form, which is e to the power iota theta. That has made complex numbers very simple and easy. You could multiply, divide, and shift them very easily. So these are some conclusions based on it. I'd request you to remember two things from here very clearly, that if z is a complex number which is given by r e to the power iota theta. So remember, this r is the magnitude of that complex number and this theta over here is the argument of that complex number. Are you all listening and understanding it? Now, sometimes you are asked to figure out the square root of a complex number. There is a short trick. What is it? Have a look at that. So this here will help you in finding the argument of, the square root of a complex number. Let's say there is a complex number z and I wish to take its square root. So first of all, calculate its magnitude. Calculate its magnitude. So add the real part of that complex number to its magnitude and subtract the real part of that complex number from its magnitude and half it. So divide that sum by 2, divide that difference by 2. Once you have done that, you have gotten the square root of the complex number by simply putting a square root over it. It will give you the real part of that square root of the complex number. Putting a square root over it will give you the imaginary part of the square root of that complex number. Now there is one slight change here. You will use either plus iota or minus iota. It all depends on the imaginary part of the original complex number. Let's say in the original complex number, iota has a plus sign before it. So it will be plus iota. In the original complex number z, iota has a minus sign before it. So it will be minus iota. That's the only change. So if you could remember this formula, this is a very useful one. But of course, when you talk about square root, it should have a plus minus over it because when they squared, plus minus will vanish. So that plus minus should be introduced in the front. Now, this is again a very important formula, de Moivre's formula people call it. So what do we do here? So here, if I say that cos theta plus sin theta, iota sin theta is raised to the power n. So this n can be clubbed with this theta, and it can be written as cos n theta plus iota sin n theta. I hope you'll remember this, and this lays the foundation for the concept of nth roots of unity. There you figure out that if you see a quadratic as x square plus x plus 1, or you see a cubic x is equal to 1. So in the real world, it has only one solution 1. But as for the complex world, it should have 3 solutions. So the 3 solutions are 1, omega, and omega square. They are called the cube roots of unity. So we know that omega and omega square are the non-real. Not always omega should be taken as a cube root of unity unless it is specified. So here we know the conjugate of omega is omega square, and conjugate of omega square will be omega. Not just that, there is something very interesting. Square root of omega is plus minus omega square. Square root of omega square is plus minus omega. And magnitude wise, the magnitude of omega and the magnitude of omega square both is 1 because they are the cube roots of unity. Thank you so much, KK. Let's continue here. Something very crucial you got to remember that 1 plus omega square is 0 and omega cube is 1. Whenever you talk about omega raised to a certain power, you divide that power by 3 and take the remainder. Omega to the power, that remainder will be the answer. Second thing, 1 plus omega square we know, but 1 plus omega to the power or r plus omega to the power 2r is given. Then it depends on two things. If r is a multiple of 3, then it will be 3. If r is not a multiple of 3, it will be 0. Remember this. This is true for cube roots of unity as well, this property. With that, when I move ahead, always remember, when you plot these cube roots of unity, 1, omega and omega square, they form an equilateral triangle. 1 lies here, 1, 0, omega is here, and omega square is here. So when you plot them, they give you an equilateral triangle, and the angle between these will be 120 degree. I hope there is no confusion on that. And the centroid of this equilateral triangle is at the origin, which means if I create a circle circumscribing this triangle, it will have its center here. So that will be the circumcenter too. It will be the incenter and it will be orthocenter because it is an equilateral triangle. These are some identities, but in terms of omega, you just take a screenshot of it and revise it after the session. Here, this is something you got to remember when you talk about trigonometry. Although we are discussing complex numbers, but we are learning it at this stage. Let's say cos theta, cos 2 theta, cos 3 theta. What does it mean? The angles are in AP. The first term is theta and the common difference is also theta. Similarly, if angles are in AP for sine as well, then there is a standard formula. It says sine n theta by 2 divided by sine theta by 2 times whole of cos of this. The same you do for sine as well. This sine and sine remain same. Only instead of this cos, sine comes into picture for this formula. I hope you remember that. With that, everyone who's watching this video, give me a confirmation. Are you all there? There. Here. This is called the Conic method rotation formula. I'll share the simplest version here. Let's say there is a vector because complex numbers can be treated as vectors. So this is z2 minus z1, a vector which is rotated by theta degrees in the anticlockwise direction, theta radians in the anticlockwise direction, which becomes z2 minus z1. So this complex number after rotation becomes z2 minus z1. And let's say its magnitude is also changed. So there what you say is that, remember this, that z3 minus z1 upon z2 minus z1 will be equal to magnitude of z3 minus z1 upon z2 minus z1 times e to the power iota theta. What if I'm simply rotating it? Why are we learning Conic method? Because this Conic method is very prominently used in coordinate geometry where you rotate a point along, when you fix a point and along with that point you rotate a point. There rotation formula comes into picture. That is the Conic method. So questions of coordinate geometry, especially based on rotation, are done with the help of Conic method. Let's have a look at that. So here, this is how you use it. I hope you'll remember it. Now the next part here is this, where you say that if I wish to verify that 3 points are collinear, one of the ways is that here I'll say z1, z2, z3, I wish to verify they are collinear. So I'll say that the distance between z1 and z2, that can be figured out by mod z1 minus z2. I hope you remember that. Good, well or model school. Second is z2 minus z3. This is that distance will be equal to the distance between z1 and z3. So if that is so, you can unhesitatingly say that yes, these 3 points are collinear. So again, something which you study in coordinates, something which you study in vectors and 3D can be applied in complex numbers. Look at that part. If there are 3 complex numbers which are representing the affixes or the vertices of a triangle, then you can find its centroid by using this formula. We all are very well aware of it. If you see, I'll simply make you revise one very standard property. I'll just draw it here separately so that you don't get confused. Let's say this is H, this is G, and this is O. What is H? H is representing the orthocenter, G is representing the centroid, and O is representing the circumcenter. This is true for any triangle. Of course, if it is an equilateral triangle, they'll all coincide. But if it is any random triangle, then H, G, and O, the orthocenter, centroid, and circumcenter are collinear for any triangle. They lie on a same line. And the centroid divides the orthocenter and the circumcenter into 1:1. Always remember that. With that, if I could move ahead with the next conclusion, what do we see? Now we talk about quadratic equations. What do we see here? Sum of the roots you already know, product of the roots you already know. This is something I want you all to know and remember and learn, that when you talk about difference of the roots, then it is given by under root d upon mod a. There is a small correction here. Difference means what? I don't know which one is greater, so I got to put a mod over it. Everyone with me so far, listening and understanding this very clearly? Can I move ahead from here? The next conclusion is, how do we convert a quadratic into a perfect square? So take a common, convert this expression into a plus b whole square, and while doing it, you get this result, which looks like y minus k is equals to a x minus h. So h comma k will be the vertex of the parabola, and this clearly looks like a parabola. Y is equals to 4ax square. Do you remember that? And depending on that, we conclude that it will be either lying above the x-axis or intersecting the x-axis or touching the x-axis, because when d is negative, x-axis lies below it. When d is 0, it touches the x-axis. When d is greater than 0, it intersects the x-axis at two distinct points. And with the help of that, with the help of sum of the roots, product of the roots, and with these observations, that how do you draw the graph of a complex number, you introduce the concept of location of roots. So of course, I cannot teach that particular concept here, but we have recorded a video, a complete one shot on quadratic equations, in which locations of roots is very, I would say, intensively discussed in that video. That's great, KK. So keep watching, keep learning. That's the intent. Let's say I'm given a biquadratic equation and it will have 4 roots, real or imaginary, whatever. So I'll say sum of the roots taken one at a time will be given by minus b by a. Sum of the roots taken 2 at a time will be given by c by a. Sum of the roots taken 3 at a time will be given by minus d by a, and so on. Do you remember that? The next learning is, whenever you see a cubic and the coefficient of x cube is positive, then it starts from minus infinity and it goes till infinity. But if it is negative, it comes from infinity and goes till minus infinity. The next part here is, if it is a biquadratic, in that case, if the coefficient is positive, in that case, it starts from infinity, comes back, goes up, comes down, goes up, and reaches till infinity. But if the coefficient of x to the power 4 is negative, then it starts from minus infinity and comes back and ends at minus infinity. This graphical visualization of these polynomials will help you in finding out the number of solutions, because IIT JEE asks questions based on number of solutions. And there you need to be aware of the graphs of cubic and biquadratic. So the curvature looks somewhat like this, not exactly like this always, but somewhat like this. This is something I would ask you to remember as a general result, because if you remember this, you could directly use it and figure out the answers. I'll simply share an example. Let's say there are 4 numbers. There are 4 positive real numbers. And I am taking the sum of those 4 numbers and taking the sum of reciprocal of those 4 numbers. Then the least value of this expression is simply nothing, but just figure out how many numbers are they. They are 4 numbers. So 4 squared, that is 16, will be the least value of it. Remember this as a result, a short technique you may call it, because it will help you in the examination hall. You can use it or prove it with the help of AMGM, or some identities are there, but remember this as a result. Now, sequence and series is what we are discussing right now. Let's say there is n AP, and its sum of n terms, Sn, is given by an square plus bn. Always remember, sum of n terms can always be given by an square plus bn for an AP, and vice versa. If somebody says sum of n terms of a sequence is given by an square plus bn, then you should not hesitate in saying or concluding that this AP, this sequence is going to be an AP. Everyone watching, listening, and understanding this, or are you all there with me? With that, what you should remember is that here, if I replace n by 1, I'll get S1. S1 means T1. So a plus b will be my first term, and nth term will be given by this. And if I wish to figure out the common difference, so S2 minus S1 will give me T2, and T2 minus T1 will give me the common difference, that will be 2a. Remember these general results, they'll help you in solving and saving a lot of time during the real examination hall. Here, we know that if you add or subtract or multiply or divide an AP by a certain scalar, it still remains AP. That is exactly what we are told. Even if you take two different APs, and take the sum or difference of the consecutive terms. There also you see that an AP will be formed, which will have its own common differences d1 plus d2 or d1 minus d2, depending on what you have done. Everyone with me? That's great. Good, well, or now. Let's say there are n terms in a GP. So I'm taking the product of those n terms of a GP. Then always remember, then product of kth term from the beginning and kth term from the end is independent of k, and it is always equal to the product of the first and last term. The same in terms of addition is true for an AP. The kth term from beginning and the kth term from end, when they are added for an AP, it is independent of k, and it will always be equal to the sum of first and last term. Do you remember that? Use these, because IITJ will ask you to use these properties in the questions. They just want to check these nuances, whether you know them or not. The next conclusion is sum of infinite terms of a GP is given by a upon 1 minus r, but the catch is the common ratio should be between -1 and 1. Then only you'll be able to find the sum of this infinite GP. The next conclusion. If the terms of a GP are multiplied or divided by a non-zero number, then it will still remains GP, but it is not true for addition or subtraction. Even if you take the reciprocals of them, or if you raise them to a certain power, then also it remains a GP. Something very crucial is, which is hidden here, if there are certain terms in AP, if there are certain terms in GP, I'll begin with this. Please remember this. There are questions asked on this property, so please remember it. Let's say A1, A2, A3 are in GP. And if I take their logarithm, so log A1, log A2, log A3, they are in AP. And vice versa is also true, which means if there are certain terms which are in AP, then their anti-logs will be in GP. Please remember this. This is a very crucial property. Here, I wish to show you something very crucial here. Let's say I'm given two terms, 4 and 9, and I wish to figure out the geometric mean. So what does geometric mean mean? Geometric mean means, just give me a second here. Geometric mean means here, hold on for a while. Geometric means that between 4 and 9, there should be pushed a term so that these three terms form a GP. So between 4 and 9, if I wish to insert 6, 4, 6, 9 will be forming a GP. And how do we find 6? The geometric mean, under root over 4 into 9. But let's say I ask you the geometric mean between -4 and 9, then you don't say that 6 will be the geometric mean. In that case, the geometric mean will be negative of under root over 4 into 9. I hope you can check it by yourself. The next conclusion is the GM between this and this and this and this will give you an imaginary number. In that case, it will be an imaginary GP. If A and G are the arithmetic mean geometric mean of two numbers, then A is A plus B by 2. G is under root AB. So I hope you remember. A plus B by 2 means 2A will be A plus B, alpha plus beta. G square will be alpha into beta. Sum of the roots, product of the roots. A quadratic can be formed, which has two roots, alpha and beta. Did you understand that statement? From here, few things you must have at your fingertips. You cannot afford to forget them. What are they? Sum of n terms of an AP, n plus 1 by 2. Sorry. Sum of first n natural numbers is n plus 1 by 2. Sum of n terms of an AP is n by 2 times a plus l, or 2a plus n minus 1d. I hope you remember that. Here, sum of first n odd natural numbers is n square. Please don't forget that. Sum of squares of first n natural numbers is n plus 1, 2n plus 1 by 6. And sum of cubes of first n natural numbers is square of sum of n natural numbers. That is square of n plus 1 by 2. I hope you'll remember that. Everyone who's watching this, understanding this. Can we move ahead from here? What I see next is, yes, when you use methods of differences. So a sequence is given, but that sequence is neither an AP or a GP. But when you look at those terms, the difference in those terms is forming either an AP or GP. So you use method of differences. But what if I tell you, instead of using method of differences, there is a short technique. What is that? Please understand this. Here, if the terms are given, and in that sequence, you see the difference between those terms is forming an AP, then remember this, the nth term of that sequence can be generally written as a n minus 1, n minus 2, b n minus 1 plus c. Now what are a, b, c? You have first term, second term, and third term. So replace n by 1, you'll get the first term. Compare them, you'll get an equation in ABC. N by 2, you get T2. Replace n by 3, you get T3. 3 equations, 3 variables, find ABC. Replace them and you'll get the answer. Have my words, mark my words. It will be more useful and easy. That's good, Velar. With that, same is true for GP as well. If the terms, the difference of the terms, the difference between the considered terms is forming a GP, in that case, nth term is given by a r to the power n minus 1, bn, and c. There again, you compare them and figure out the value. But what is the r here? R is the common ratio of that GP, which you are getting after the difference. I hope you'll remember that. Moving ahead with the next conclusion, I'd like to share a shortcut for solving specifically this category of questions based on VN method. I have brought an example. Understand this. The constraint here is that this should be forming an AP. So terms should be in AP. First conclusion. Second conclusion, it started, the second term starting with 3 should be the second term here of the first term. Third term starting with 5 should be the second term of the second term. I hope you're understanding it. So each of these terms are having 5 terms in product. Now I need to figure out its sum. So one of the methods is telescoping sum, the VN method. The other method is the shortcut. What does it say? Take this difference, 9 minus 1. What is it? 8. Write 1 by 8. Answer is there within this next 10 seconds. What is the answer? Write the first term. Which is the first term? This one. But remove the last term from it. Minus. Write the last term, but remove the first factor from it. And that will be the answer. Did you understand the whole approach? I'm leaving you with this and you will be able to find its answer. Let's say infinite terms sum is needed to be found. Then this will be approaching 0 because when n approaches infinity, this will be approaching 0 and this will be the answer. Isn't it interesting and easy? And you could solve these questions within seconds. Here, inequality is based on logarithm. Please remember, it all depends on the base. So here, if log x is greater than log y, I need to look at the base. If base is greater than 1, the same relation will hold true between x and y. But if the base is between 0 and 1, the sign changes. The sign changes. It means x will be less than y and both should be positive, of course. The same conclusions can be drawn here when you take anti-logs. Something related to factorial, you got to remember them. What do I mean by that? Few basic properties are there. If I could highlight the important ones, you should remember this one, that x factorial and y factorial are given equal. Then you don't always conclude that x and y are equal. There, of course, either x or y could be equal, or x could be 0 or y could be 1, or x could be 1 or y could be 0, because the problem is 0 factorial and 1 factorial both are 1. So remember that, right? Moving towards the next part, let's say I am asked to figure out how many 3's are there in 100 factorial. So do one thing, divide 100 by 3. What you get is 33. Divide 33 by 3, that is 11. Divide 11 by 3, you get 3. Divide 3 by 3, that is 1. Stop here when you start receiving the quotient as 0. I'm taking the integral part only and add all these values. That is nothing but the number of 3's which are there in 100 factorial. Did you understand that short tree? This is basically union formula which you all must be aware of. I need not explain this, but yes, do remember this. Here, some basics of permutation and combination. What do I mean by that? Let's say R objects are to be selected and arranged out of N objects. It is always done in NPR ways. You know the formula. But if out of those N objects, some are alike, some are of the same type, then how do you arrange it? N objects at N places can be arranged in N factorial ways, but the alike ones are not forming any different arrangement. That's why we divide the number of P factorial, Q factorial, R factorial. I hope you remember that. Similarly, let's say N different things are there and each thing may be repeated any number of times, then it can be done in N to the power R ways. Remember that? I'm just making you revise these formulae. Here, how do you remember NCR? NCR is nothing but what? N factorial upon R factorial into N minus R factorial. But what does it mean? It means selection of, just choosing selection of R objects out of N objects. It's not an arrangement here. So if it is simply a selection, then you say that NCR needed to be done. So every permutation is a selection first. So NPR is always NCR into R factorial. So you select first and then you arrange. That is permutation. I hope you got my point. With that, when I move ahead, remember, these are some very basic properties. A very important Pascal identity is what on which ITJEE loves asking questions. What is it? NCR plus NCR minus 1 is always N plus 1 CR. How I personally remember it, this is not you can. Of course you can, but I personally remember it like this, that if this and this value is same, and if this value and this value is consecutive, then all you got to do is increase this value by 1 and take the bigger value between these two values. Did you get my statement? Of course, the other values you should simply remember. They are the basic properties which you can learn. Something very simple is what I want to highlight here again. This part again. If NCX is equal to NCY, do you remember? X is equal to Y could be a possibility, but the other possibility could be X plus Y will be equal to N. Do you remember that result? I hope you all are watching, listening, understanding, and revising all the formulae of IIT JEE mathematics through this revision video which we have brought for you here. This is something which we use in binomial as well. So listen to this part very carefully. It is basically an extension of permutation and combination, but we use it in binomial as well. So what does it say? The first statement says that if n is even, NCR will be greatest for R is equal to 1 by 2. So the middlemost term. But if n is odd, there will be two middle terms, and the two middle terms will be NC n minus 1 by 2 and NC n plus 1 by 2. We all know that NC0, NC2, NC1 until NCn will be 2 to the power n. But if I take simply the even terms or the odd terms, it will be 2 to the power n minus 1, half, right? And the same results can be drawn here as well. Something very crucial, let's say there are n different things. I need to select them, but I need to have at least one of them. I repeat, the number of ways, combination, selection of n different things, selecting at least one of them. So with each object, I have two choices. Either I take it or don't take it. So with n objects, I'll have 2 to the power n choices. But if I take that one possibility in which I'm not choosing any object, so I am supposed to choose at least one object. So that possibility I need to discard where I'm not selecting any object. So 2 to the power n minus 1 will be those number of ways. Can we move ahead from here? Yes. Now the next part is the number of combination of n identical objects taking r objects at a time is 1. Because if let's say you approach a vendor, a shopkeeper, a fruit seller, let's say, and it has all the oranges in the shop. So all the oranges are, let's say, identical, absolutely identical. So let's say in how many ways can you choose 5 oranges? Whichever 5 oranges you choose will be same, which will be identical. So you cannot segregate or differentiate the ways. So there is only one way in which you can have 5 oranges. Understood my statement? Now, similarly, let's say if I ask you, let's say in the shop there are 100 oranges. How many ways can you have any number of oranges, including 0 number of oranges? That will be 100 plus 1, that is 101. That is, either you choose 0 oranges or 1 orange or 2 orange or 3 oranges. These are all one ways only. I hope you are understanding it. From here, when I move ahead, the same can be concluded from this part. Let's say you go to a party, party, let's say, there different types of dishes are there. One type of dishes is there in A1 varieties, second is in A2 varieties, third is in A3 varieties. So in how many ways can you feed yourself? So first dish which has A1 types of variety can be eaten in A1 plus 1 ways, second in A2 plus 1 ways. But in all of these ways, there will be one way in which I'm not eating anything because that way is also included. So this one needs to be subtracted from here. Moving ahead with that, what do we see? Number of divisors of n. Just look at these formula sheet. We have done it in PNC. Just look at this part, take a screenshot of it, and you will make or able to get a good sense out of it. Moving ahead with the next part, what do we see? Yes. Let's say I have 12 objects, right? And I wish to divide these 12 objects into two groups in which one of the group has a size of 7 and the other group has a size of 5. So this is it. 12 factorial upon 7 factorial into 5 factorial will be my answer. This is division, but I wish to distribute into two groups, A and B. So A group can be of the size 7 or B group could be of the size 7. So when division with distribution comes into picture, I need to distribute it to two groups. So 2 factorial will come into picture. That's exactly what is written over here to make you understand this concept. I hope there is no confusion on that front. Something very crucial I would request you all to remember is this particular part. Which part? This one. Let's say n identical objects are there and they are to be arranged in r places, at r places. That can be done in n plus r c minus n plus r minus 1 cr minus 1 ways. Always remember this result. I hope you wouldn't forget that. This is called dearrangement. What do I mean by dearrangement? Let's say I have 5 letters, but I wish to send these 5 letters to 5 friends of mine, but I should ensure that no letter reaches to its correct or the right destination. That is called dearrangement. So the dearrangement of 5 objects is given by 5 factorial into 1 minus 1 by 1, 1 by 2, 1 by 3 until 1 by 5 factorial. I hope you'll remember it. I will ask you to remember at least the values of d1, d2, d3 till d5. So calculate it and have it at your fingertips. The next conclusion is some algorithms I'm giving you to deal with questions based on PNC in geometry. For example, let's say I am given n points and I wish to have a number of lines, that how many lines can I form out of these n non-collinear points. Then I'll say I'll be able to form NC2 lines. I hope you got that. So this is how you work out. So remember these are the general formulae. Simple standard formulae there, you can understand them by the moment you look at them. This is called the binomial expansion. How do we use it? Just give me a second, everyone. How do we use this binomial expansion, students? Have a look at it once. All right. So what do we see here? I hope you know binomial expansion. It's a very simple phenomena. X plus a to the power n. NC0, NC1, NC2 will be the coefficients. What do you see with x? X to the power difference of these two, NC1, n minus 1, NC2, n minus 2. The power with a will be this one, 0, then 1. So this is how you generalize it. So if I wish to write the r plus 1th term, r plus 1th term is given by NCR, x to the power n minus r, a to the power r. I hope you'll remember it. You wouldn't forget that. Now, moving ahead with the next part, what do we see? If in this x plus a, I expand 1 plus x. So this is how the expansion looks like. It simply can be concluded by NC0 x to the power 0, NC1 x to the power 1, and so on. With that, let's say somebody asks me to solve a question where they ask you to find out the p plus 1th term from the end in the expansion of x plus a to the power n. Then don't put much efforts in solving it. Just remember that it will be same as p plus 1th term from the beginning in the expansion of a plus x to the power n. Will you remember that? Now, moving ahead with the next part, what do we see? Yes, this is something we have discussed in the last video as well. Always remember that when you talk about finding out the rational terms and the irrational terms, then yes, write the general term. Then of course a and b are prime, so 1 by p, 1 by q will have the powers as a n minus r to the power n minus r by p, r by q. So ensure by observation that how do you make these values integers so that you can have the rational terms. And by having so, you can figure out the number of rational terms. Now, moving ahead with the next part, what do we see next here? Yes, this is a shortcut which I would ask you and urge you to remember because JEE asks questions on it. How do we use this short technique? Learn this. Let's say we are given x plus a to the power n. And for a certain value of x, we are asked to figure out the greatest term in this expansion. In the question, they may say that for the value of x as 3, find the greatest value in this expansion. Then how will you do it? The idea is really simple here, students. What you will do is, first of all, you should have a 1 here. Or instead of all this, first of all, of course, you should have a 1 here. Or simply forget this, just find out m. Now, how do we find out m? To figure out m, all you need to do is mod of x by a n plus 1 upon mod of x by a plus 1. What is x? X will be given. You will be given a value, a certain value of x. Let's say x is 3 or 5 or something like that. When you find this value, this expression, when you solve, you get a value of m. That value of m could be either an integer or it will not be an integer. If it is an integer, then tm and tm plus 1 are the greatest term. If it is not an integer, then t, gi of m plus 1 will be the greatest term. Remember this. Yes, if this is something we have already discussed, I'm not explaining this part. This is something you should remember. x minus 2y plus 3z to the power n. This needs to be expanded. A trinomial expansion it is, and you need to find out this sum of all the coefficients. Don't expand it, just replace x, y and z by 1. Replace x, y and z by 1. So 3 minus 2 is 1, 1 plus 1 is 2, 2 to the power n will be the answer. I hope you can see the next example as well. Remember, x to the power n minus a to the power n is always divisible by x minus a. Of course, n should be a natural number. But when you talk about x to the power n plus a to the power n, then it is divisible by x plus a, but n should be an odd number. Then only it will be true. The next conclusion, multinomial theorem. How do we do it? So instead of two terms, binomial has two terms, by 2. It is multinomial, multiple terms. So with this multinomial expansion, the standard generalized term is given by summation of x1 to the power alpha, x to the power alpha 2 and so on, where summation of n factorial upon alpha 1 factorial, alpha 2 factorial and alpha k factorial, where summation of all of these alphas should be n. Did you get that part? Now, in a multinomial expansion, if somebody asks you that how many distinct terms will exist, then you always say n plus k minus 1, ck minus 1. What is k? K is the number of terms present here. That is k, n is n, and I hope you know how to do it. Now, moving ahead with the next part, determinants. We know a shortcut to expand a determinant. Let's say there is a determinant given by a1, a2, a3, b1, b2, b3, c1, c2, c3. So you repeat the first two rows, and then you take the product along the principal diagonal elements, you denote it by p. You take the product along the non-principal diagonal elements, you denote it by n, and p minus n gives you the value of the determinant. You remember cofactor in minor as well. With that, you can find out cofactor in minor as well. Remember, if the elements of any row are, if multiplied with the cofactors of that row, corresponding cofactors of that row, you get the value of the determinant. But if you multiply the elements of any row with the corresponding cofactors of some other row, then the value of the determinant will be 0. Remember this. It's a important fact or a property. Let's say I have created a determinant by having the cofactors. So there was a determinant. I have formed a determinant by having the cofactors of a determinant. And if I wish to figure out the value of this determinant, then the determinant you have by having the cofactors of a determinant, it will be equal to determinant of that original elements raised to the power n minus 1. For example, it is a 2 by 2 matrix or a 2 by 2 determinant, then it will be delta to the power 2 minus 1, that is delta only. If it is a 3 by 3, then it will be delta to the power 3 minus 1, that is delta square. Remember that. Can I move ahead from here? Are you all listening, understanding and learning whatever we are explaining here in this video? Everyone with me so far? Can I continue from here? Everyone with me? Just give me a response quickly. With that, here. How do we use determinants in coordinate geometry? Let's say there are three lines, a1x b1 by c1, a2x b2 by c2 and a3x b3 by c3 is equal to 0. Let's say I wish to verify whether these three lines are concurrent or not. What do I mean by concurrent? That they all should be passing through one single point. Then for concurrency, the determinant a1 b1 c1, a2 b2 c2 and a3 b3 c3 should be 0. That's good, Tanushri. I hope all the other participants are also there. Similarly, let's say I'm given a second degree equation. And I need to verify or validate whether this represents a conic or a pair of straight lines, because there are two possibilities. It represents either a pair of straight lines or a conic. So if it represents a pair of straight lines, then we say AHG, HBF and GFC. How I remember it? ABC, HGF, HGF. If this determinant is 0, then it represents a pair of straight lines. Otherwise, conic, parabola, ellipse, hyperbola, circle. When you talk about, let's say you are given three equations in three variables, and when you talk about it is having unique solution, then delta should be non-zero. If delta is 0 and delta 1, delta 2, delta 3 be non-zero, or at least one of them is non-zero, then we say no solution. But if all of four, delta, delta 1, delta 2, delta 3 are 0, then we say infinite solutions. Do you remember that? But if it is a set of or system of homogeneous linear equations, this means the constant terms are 0, then two possibilities are there, trivial solution or non-trivial solution. Trivial solution means what? X, Y, Z should be 0 and that's the only solution. This will have a trivial solution if delta is not 0. But if delta is 0, it will have a non-trivial solution, which means X, Y, Z, non-zero values of it will also satisfy it. Remember this. This is something on which JEE asks questions every year. And of course, on this also they do ask questions. Moving ahead with that, some standard determinants you should remember. Take a screenshot of it. You should remember them so that you can save time. The moment you see this, replace it by this. Remember these standard expansions. Take a screenshot here. Any matrix can be represented as a sum of two matrices where one of them is a symmetric and the other one is a skew-symmetric matrix. So if you want more clarity on it, I have created a complete explanation on it in the one shot of matrices and determinants here. These are some properties. Every single property, one after another, is explained by me. Just have a look at them. If you want to understand the explanation of each of one property, you can watch this session, one shot on that. But as of now, just read them so that you get more clarity on them. Here, always remember, determinant of a matrix or transpose of it will be equal. Determinant of product of two matrices. So determinant is distributable over product, so you can do that. And few more properties like that, that if a scalar is there with the matrix, and if you take the determinant of it, then scalar comes out with power n. Remember that. Similarly, a to the power n or determinant a to the power n will be same. If there is a diagonal matrix, then determinant of that matrix is product of the diagonal elements. Remember few basics, you will definitely save a lot of time. This is, I would say, one of the most important slides of this particular entire session. Trust me, have words, have faith in my words. Adjoint, determinant, IIT loves it and they ask questions based on it. 2 to 3 questions you'll be seeing every shift, every pattern from matrices determinants, and 1 or 2 of them will definitely be using these properties. So pay very much attention to this particular slide. It is a very important one. All the students who are watching it right now. Remember, matrix A times adjoint of it or adjoint of this times A will be determinant of A times identity matrix. That lays the foundation for inverse of a matrix. Here, determinant of adjoint of adjoint of adjoint of adjoint of A, if adjoint is appearing m times, is given by determinant of A to the power n minus 1 raised to the power m. N minus 1 raised to the power m. Remember this. Remember this. Similarly, if adjoint of A is needed to be taken, it is given by determinant of A to the power n minus 2 times matrix A. What is n? The order of the matrix. Now, with that, few more are there. I hope you can understand them by yourself. When you take the inverse of a product, then the order changes. The same with transpose. You remember that? Moving ahead with the next part, what do we see? This is related to odds in favor, odds against. So let's say when somebody says odds in favor are A is to B. So probability of happening of that event will be A upon A plus B. And the probability of not happening of that event will be B upon A plus B. The next property is, this is what union, we already know, Bayes theorem. Let's say an event can be separated into these two branches A and B, but A concludes with R and T and B also concludes with R and T. But I want the probability of happening of A when I know that R has already happened. So Bayes theorem says probability of happening of A when R has already happened divided by the total probability. I hope you remember that. With that, when I go ahead, we see the binomial distribution of probability. I hope you remember this. Let's say there are few things you should remember. Let's say whenever I ask you mean, so mean is given by n into p. N is number of trials, p is success, the probability of having a success. NPQ, n is number of trial, p is probability of success, q is probability of being non-success, having no success. What is under root NPQ? That is of course your standard deviation, because standard deviation means under root over variance. Do you remember that? With that, I hope you remember this. You can understand the definition of success by simply reading it. I'm not explaining this part because it is self-explanatory. This is something I have kept here additionally just to make you understand that how a game of cards is played so that you can have a more clarity of this. This is something I have deliberately kept to make you understand the number of 1-1 mapping, the number of 1-1 onto mapping, the number of many-1 mapping. If you divide it by total number of functions, you will get the probability of having that kind of mapping. I hope you will understand it. The next part, dearrangement. I don't know why has it come here, but I think this is how dearrangement will play. So when I asked you the value of D1, D2, D3 while discussing dearrangement in permutation and combination, so D1 is given by 0, D2 is 1, D4 is 9, D5 is 44. You simply get the values by putting n as 1, 2, 3, 4, 5 here respectively. Remember that. Now we move towards the next part, which is called trigonometry. Let's take a 5 minutes break, then we'll resume. So when we start discussing or revising the formula of trigonometry, it is 3:15 right now. We'll resume at 3:20. Okay, Let's take a 5 minutes break. Hello, hello, hello. I hope I'm clearly audible. All the participants, just give me a quick response. Hanuman, nahi. I'm really sorry. Hanumesh, I'm really sorry. So Hanumesh is asking, I have a doubt. My JEE Mains exam is on 22nd. I hope I'm clearly audible and visible. Just give me a quick response. If I'm not, do write it. All the students who can listen and watch this, come back. So I have for Aadhaar, I have it in card form, but not as a long sheet form. Can I take it in card form, PVC card? If it is the original Aadhaar card, if it is the original Aadhaar card, or it usually takes 5 to 10 rupees, get a color printout of it. When in doubt, just go for the English way. So take a color printout, right? Okay, great. Good, Tanu. So let's get started. We'll be resuming with now trigonometry here. How do I proceed with that? I'll be simply showing you a lot of identities which you already know. Some of you already not aware of, then have a look at them. We know these three, the basic ones which you have studied since 10th standard. I'll not be revising them. This is how you convert a trigonometric ratio into other trigonometric ratio. So with the help of these only you convert them. For example, let's take the example of sine theta. It can be written as 1 upon under root over 1 plus cot square theta. Why? Because when you rearrange it, you get this. I hope you understood this. So when you talk about quadrant theory, so whenever you move from x-axis, either upward or downward, the ratios don't change. But when you move from the y-axis, the ratios change. Sine into cos, cos into sine, tan into cot, cot into tan, sec into cosec, cosec into sec. And of course, do remember about the sine. First quadrant, all positive, sine and cos, tan and cot, cos and sec. Do you remember that? Great. The next one will be the graphs of them. Please understand, look at the graph of sin x, 0, pi, 2 pi. These are the points where sin x becomes 0. At the 4n plus 1 category of multiples of pi by 2, it becomes plus 1. 4n minus 1 category of multiple of pi by 2, it becomes minus 1. Here, at the odd multiples of pi by 2, cos x becomes 0. But at the 0, pi and also at the odd multiples of pi, it becomes minus 1. At the even multiples of pi, it becomes 1. For 10x, we know it is clearly an increasing function. If I look at in this interval, minus pi by 2 to pi by 2, minus pi by 2 and pi by 2, x is equal to minus pi by 2 and pi by 2 will be the asymptotes here. And here, we can clearly see that at these points, it goes not defined at all the odd multiples of pi by 2. Everyone, are you there watching, listening, and understanding this session? I hope I'm clearly audible and visible because I see no activity on the screen. Am I clearly was audible and visible? Great, great, great. So screen froze for me. I hope it is there visible and you can see me on the screen properly. Can we continue with that? Now, from here, what I see next is, yes, these identities. Remember it. It is one of those very crucial ones. Sin a plus b into sin a minus. It's like a plus b into a minus b, a square minus b square, but in a little different format. So it is sin square a minus sin square b. But for cos a plus b into cos a minus b, it is cos square a minus sin square b. Please remember it. Here we know that product into sum, we know how to convert it. This is what we have discussed while discussing integration as well. Now, moving ahead with that, what we see, sum into product, sin a plus sin b. You remember that, sin c plus d plus sin c minus d. If you do that, you will get these kind of conclusions. So these four formulae you must have been using. You know the proofs as well. These are the ones which I'll ask you to memorize. Please by heart them. IIT asks them. Sin 2a, 2 sin a cos a we know, but the other 10 version of it is very widely used. They ask you half angle formula. Let's say they ask you sin 7.5 degree. There, these formulae come into, they become very handy. For example, cos 2a, it is cos square theta minus sin square theta, or 1 minus 2 sin square theta, or 2 cos square theta minus 1, or the third 10 version is 1 minus tan square theta upon 1 plus tan square theta. And of course, half angle formula means what? You replace 2a by a. So it becomes cos a, then it becomes cos square a by 2 minus sin square a by 2. I hope you're understanding this. So this is how I remember them. Similarly, triple of it. The ones which we have simply revised previously also, I hope you wouldn't forget them. As it is direct, this formula based questions are asked by JEE Mains. Please remember them. They do ask it. They are asking it everywhere, questions based on that. So I hope you'll remember them. These are the values. Of course, you cannot remember them, but few if I could highlight, then go with 7.5, because if you remember 7.5, you can work out the other values. Go with 18 degree. This is very prominently and widely used. Don't forget that. So these are the few ones which you should have at your fingertips. Something very crucial, a sin theta plus b cos theta, its maximum and minimum value will be under root a square plus b square will be maximum. Negative over under root over a square plus b square will be its minimum value. Everyone listening, watching and understanding this? The next is, general results. Although trigonometric equations is omitted from the syllabus, but we see every year questions being asked. So these are the general results. If you know the graphs, if you know the graph of sine theta, cos theta, tan theta, then you can understand these results very easily. This is simply an extension of those graphs only. With this, when you talk about inverse trigonometric functions, remember the domain and range are changed here, and we go for principal domain, principal range specifically here. So yes, the range of sin x becomes the domain here, and we see it in the principal value branch, which is from minus pi by 2 pi by 2. So sine, tan, and cosec are almost similar up to an extent to understand. And cos inverse, sec inverse, and cot inverse are on the same page. Why am I saying so? Just let me give you more clarity on that front here. The idea is minus pi by 2 to pi by 2, minus pi by 2 to pi by 2, and here minus pi by 2 to pi by 2. Of course, for 10, equality is not there. I hope you know the reason. For cos, sec, and cot, 0 to pi, 0 to pi, 0 to pi. But I hope you understand, for cosec, you cannot have 0, and for sec, you cannot have pi by 2 in the range. I hope you're understanding why. Similarly, here, when you talk about domain, sine and cos inverse will have the same domain. You know the reason. For tan and cot, you'll have the same domain. You know the reason. And for cosec and sec, you will have the same domain. I hope you understand the reason. If you know the original trigonometric functions, their inverse, understanding them is a simple task. Some properties which are self-explanatory, for example, sine inverse of sine theta will be theta, but theta should be between minus pi by 2 and pi by 2. You cannot have it always as theta. That's a question. I'm willing to nullify this sine inverse by sine, and I wish to write this theta. So I should have this clarity that this should be the principal value branch. This theta should lie between minus pi by 2, pi by 2 only. If it does not, then I first of all, by using the cyclicity, the periodicity of trigonometric function, I need to bring this theta between minus pi by 2 pi by 2. Then only after doing so, I can cancel or nullify this sine inverse by sine. I hope you're understanding the intent. The same needs to be followed for the other ratios as well. Same. This is different. This is not same as sine inverse of sine theta. This is sine of sine inverse of x. So previously that was theta, angle. This is x. This is the value. I hope you're understanding the difference between that. So sine of sine inverse x is x, but again there is a catch. X should be between minus 1 and 1, because sine inverse, for its domain, its function to be defined, the domain is from minus 1 to 1. It does not take any value less than minus 1 or greater than 1. So you cannot say that, let's say in a question it is written that sine of sine inverse 5 and you write the answer as 5. No, sine inverse 5 is not defined first of all. Getting my point, everyone? With that, I hope the same holds true for the other set of inverse trigonometric functions. There again, that concept comes into picture. I said sine, tan, and cosec behave similarly. See, they behave like odd functions in inverse trigonometric functions. Sine inverse of minus x, minus of sine inverse x, tan inverse of minus x, minus of tan inverse x, cosec inverse of minus x, minus of cosec inverse x. For cos, sec, and cot, it is pi minus. It is pi minus. Of course, you should not do anything with the domain. Don't touch it. Don't touch the domain. It should remain intact. For reciprocals, yes, this is true. Sine inverse of 1 by x is cosec inverse x. That, I think, is self-explanatory. Here, you got to remember this. Sine and cos are complementary in terms of angles. We know that. So sine inverse x plus cos inverse x will be pi by 2. Tan inverse x plus cot inverse x will also be pi by 2. Sec inverse x plus cosec inverse x will be pi by 2. But the catch is, x should be between minus 1 and 1 for sine inverse x and cos inverse x. For here, tan and cot, it can be any real number. But again, for sec and cos, it should be either less than minus 1 or greater than 1. For tan, I will request you memorize it by heart along with these cases. From inverse trigonometric functions, questions are asked. Let's say a question uses sine inverse x plus sine inverse y. Then convert it into tan inverse x plus tan inverse y and use this identity. So don't learn a lot of identities. Learn this one, convert those into tan inverse and apply this one. So 3 variants you got to remember. If the product of x, y is less than 1, use this. If x and y both are positive but the product is greater than 1, use this. If x and y both are negative but still the product is greater than 1, use this. This is how you use them. Everyone with me so far, watching it, understanding it clearly. Can we move ahead from here? Here. What I do next is, now we will move towards the next part, or the final part of our session, with which this session gets over, coordinate geometry. Look at this. Can we get started here? I'll start with this part. I'll make you understand the section formula. internal division and external division. Let's say there is this point which divides it internally. This length is n, this length is n, or the ratio is, let's say, m is to n. So we remember m goes to this, n comes to this, and if it is an internal division, we use plus. If it is external, we use minus. Distance formula, I think I need not make you revise. This is what I was mentioning in 3D, which we'll be using in 2D as well. What does it mean? There is a line segment created by joining AB, x1, y1, x2, y2. There is a line P, ax plus by plus c divides it into the ratio lambda is to 1. One of the ways is you find coordinates of P in terms of lambda, you put it here, and then you find the value of lambda. Other way could be you use this short trick. The short trick says the ratio lambda is to 1 will be negative of power of this point with respect to this line divided by power of this point with respect to this line. That will be the answer. Remember this. This is one of those short techniques which you're supposed to remember. Of course, after putting this negative sign, when you solve it finally, if this value still turns out to be positive, which means line is dividing it internally. If it is negative, line is dividing it externally. Don't forget that. Whenever you're given a polygon, just hold on for a while. Give me a second. So how do we find the area of a polygon? This is a very simple idea. It's a very straightforward approach. Let's say there is a polygon, x1, y1, x2, y2, x3, y3, x and yn are the vertices of that polygon. All you need to understand is stair method says half of modulus means positive of stair of. You start with any vertex, just follow the order cyclicity clockwise or anti-clockwise, x1, y1, x2, y2 until you repeat the last. The first with which you started with, that vertex should repeat again, and then you take the stair. Stair means this into this minus this into this plus this into this minus this into this plus this into this minus this into this. This gives you the area of any polygon. You remember in 8th, 9th, 10th you have learned a lot of formulae for different shapes, but coordinate geometry boils down all those formulae to one formula, stair method. That's the beauty of simplifying and generalizing the results. Here, this is a very important result. Please remember it. How I ask you to remember it. Let's say there is a triangle. There we see a triangle. This triangle has, let's say, vertices. The vertices are x. Okay, let's say I'm not given the vertices, but I'm given the midpoints. So this is the midpoint of this edge or this line or this side. This is the midpoint of this, and this is the midpoint of this side, right? So these are the midpoints. So let's say this midpoint is given by A, this is given by B, this is given by C, or they are using EFD. Okay, so let me say, let's forget this one. Okay, so this is what I'm saying. So let's say I want to define this vertex. Let's say this is D. So D will be given by B plus C minus A. B plus C minus A means x coordinate of B plus x coordinate of C minus x coordinate of A will give you the x coordinate of D. Similarly, for y coordinate also you're supposed to follow the same. The same can be followed for here, this E as well. E coordinate will be given by C plus A minus B. F will be given by A plus B minus C. Everyone with me so far? Did you understand that these short techniques are basically some generalizations which are coming from observations only? Now, moving ahead with the next part, this is something we have already discussed. This is what you got to remember. Circumcenter of a right angle triangle is on the midpoint of the hypotenuse. What does it mean? Let's say there is a right angle triangle like this. And if I circumscribe it, so this is the circumscribing circle. And if I ask you to find its center, will you help me with its center? We know that this circle is passing through the vertices of this triangle, which is the right angle triangle. So if this chord of this circle is subtending a 90-degree angle on its circumference, then this chord should not just be a chord, but it should be a diameter, because diameter subtends a 90-degree angle on the circumference of the circle. So with that, for a right angle triangle, the circumcenter is nothing but the midpoint of the hypotenuse. Don't forget that. These are some basic properties which IITJ uses in its questions. We know that these are some basic conclusions which you can understand and read and understand and learn. This is something we have studied in vectors in 3D as well. I'm just giving you the general result. Simply remember, in center, circumcenter, orthocenter, everything can be given by you. All you need to do is x1, x2, x3 in the numerator, m1, m2, m3 in the denominator, and x1, x2, x3 will have m1, m2, m3 as their coefficients. Same will be true for y. Now m1, m2, m3 you should replace and you will get the values. What do I mean by that? Let's say I need centroid. So replace m1, m2, m3 by 1. So x1 plus x2 plus x3 by 1 plus 1 plus 1, that is 3, will give you the centroid. Did you understand that? If I replace m1, m2, m3 by sin A, sin B, sin C. So sin A into x1, sin A into x2, sin C into x3 upon sin A plus sin B plus sin C will give you I, which is in center. The same will be true for orthocenter, circumcenter. I have given you a complete list here. Did you get that? Can I move ahead from here? From here, when I go ahead, let's say I am given two straight lines which are having their slopes m1 and m2. If I wish to figure out the angle between these two straight lines, the formula, the acute angle theta is given by tan inverse modulus of m1 minus m2 upon 1 plus m1 m2. If lines are parallel, m1 will be equal to m2. If lines are perpendicular, m1 plus m2 will be minus 1. Do you remember that? Here. This is called the parametric form of a straight line, which you can relate it with the 3D version of a straight line. So if a line is passing through x1 comma y1 and or r distance away from it, there is a point x comma y. So I can take it like x minus x1 upon cos theta, direction cosines. Y minus y1 upon sin theta is equal to r. This is nothing but what? Y minus y1 upon x minus x1 is equal to tan theta. That only. So r distance could be either upward or downward. So if it is r distance upward, I'll take it as plus r. If it is r distance downward, I'll take it as minus r. So parametrically, a point x comma y, r distance away from it on this line x1 comma y1 can be defined as x1 plus r cos theta, y1 plus r sin theta. Depending, if it is above, r will be positive. If it is below, r will be negative. Everyone with me so far? Can I move ahead from here? With that, when I go further, we see that yes, a point's position with respect to a line can be defined with respect to the power. Are you all there? All the participants who are watching it right now, just give me a quick confirmation. Everyone with me so far? So how do we define it? Yes, that you find the power of that point with respect to the line. Power means what? Pass the coordinates of that point into that line. If it is on the line, it will be 0. But if it is above or below the line, it will be positive or negative depending on the segment where it is. So if the power of this point and this point with this line is same in terms of sign, if both are positive, they lie on the same side. But if they lie on the opposite side of the line, the powers will be opposite in sign. One will be positive, other will be negative. I hope you got my point. How do you find the perpendicular distance of a line from a point? It is given by power of that point with respect to that line divided by under root over a square plus b square. But you take modulus because it is distance. If let's say there is a point P, x1 comma y1, from this point P, I have dropped a perpendicular on a line ax plus by plus c, and I wish to figure out the coordinates of the feet, which let's say I'm denoting by x2 comma y2. Then formula says x2 minus x1 upon a, y2 minus y1 upon b is equals to negative of, mind you, negative of power of ax1 plus by1 plus c upon a square plus b square. You don't put an under root here. Under root was put here in distance formula, but here you don't put it. Let's say I wish to find out the mirror image. Then replace this minus 1 by minus 2. Will you remember that? With that, if I move further, what I see next is circle coming into picture. Everyone with me so far? Are you all listening, learning and understanding? What we see that for a circle, its center is h comma k, its radius is a. For equation is given by x minus h whole square plus y minus k whole square is equals to a square. A point parametrically on this circle can be taken as h plus a cos theta, k plus a sin theta. So if the circle is a standard circle, x square plus y square is equals to r square, its center will be at origin 0, 0, its radius will be r. So a point parametrically on the circle will be given by r cos theta, comma r sin theta. Are you all there, everyone? Just give me a quick response. With that, let's say this is a second degree equation. It represents a circle first of all if the coefficient of x square and y square are same. So divide that by coefficient so that it becomes 1, the coefficient of x square and y square. Now by comparing this and this, so take the negative half of the coefficient of x and y, that will give you the center. And under root over g square plus f square minus c will give you the radius. And if the radius is positive, then only it is the real circle. If g square plus f square minus c is 0, it is point. If it is negative, it is an imaginary circle. Yes, this is something, let's say diametrically opposite points are given of a circle's diameter. Then how do we write the equation of that circle? X minus x1, x minus x2 plus y minus y1, y minus y2. Something very crucial you got to remember is that diametric form of circle can also be written as x square plus y square minus x times sum of abscissa of the diameters, extremes of the minus y times sum of the ordinates of the extremes of the diameter plus x1, x2 plus y1 by 2. Remember this. It is basically a mixture of two quadratics, one quadratic in x, other quadratic in y. So if one quadratic in x and one quadratic in y gives you the roots, then those two roots will be having x and y coordinates of the extremes of the diameter. Remember that. Here, this is basically a formula which gives you the idea that any point is given either on the circle, in the circle, or outside the circle, and its minimum and maximum distance is needed to be found from the center, from the circle. Then the formula is simple. Distance between the point and the center of the circle plus r will be the maximum distance of that point from the circle. Distance of the point from the center of the circle minus r, you take modulus of it, it will be the minimum distance of that point from the circle. Remember this. Let's say from an external point, a tangent is drawn to a circle and you need to figure out the length of this tangent. It is given by under root s1. Remember that. From that, when I move ahead, tangent at any point x1, y1 on the circle is given by t is equal to 0. I hope you remember. How do we write t? So for t, you remember x square is replaced by xx1, y square is replaced by y1, x is replaced by x plus x1 by 2, y is replaced by y plus y1 by 2. Of course, in a circle, you don't have a term in xy, but if for a hyperbola, if there is a term in xy, you replace xy by xy1 plus yx1 by 2. So by writing t is equal to 0, you can write the equation of the tangent lying from a point on the circle. The same will be true for a parabola, ellipse, and a hyperbola as well. So I won't repeat it in those three chapters. Now, here, let's say if I write t is equal to s1. How do you write t? This is your t. S1 means power of that point with respect to the circle. So t is equal to S1 gives you the equation of the chord which is bisected at a point x1, y1. This is something you all have studied in coordinate geometry and we are just revising it. Let's say the distance between the centers of the circle, is greater than the sum of their radii. Then the circles are disjoint. The number of common tangents will be 4. If the distance between the centers of the circle is equal to the sum of their radii, they are touching each other externally, the number of common tangents will be 3. Everyone with me so far, watching, learning and understanding it? The distance between the center of the circles is greater than the difference of the radii and less than the sum of the radii. They'll be intersecting at 2 points. The number of common tangents will be 2. If the distance between the centers of the circle is equal to the difference of their radii, then they are touching each other internally, the number of common tangents 1. If the distance between the centers of the circle is less than the difference between their radii, then they don't touch at all and the one circle lies completely inside the other circle. The number of common tangents will be 0. Now let's talk about a parabola. What do I mean by that? Here, we know that for a parabola, eccentricity is 1. For ellipse, it is less than 1. For hyperbola, it is greater than 1. I hope you remember that. Something very crucial here, students, that the quadratic, the second degree equation, ax square plus by square plus 2hxy plus 2gx plus 2fy plus c is equals to 0 could represent either a pair of straight lines. That happens when delta is 0. But if delta is not 0, it represents a conic. Delta means ABC, HGF. Do you remember that? So with that, it will represent a parabola if h square is equals to AB. So by looking at that second degree equation, by doing this calculation, you can predict what kind of conic it would be. And questions are asked based on that. If h square is less than AB, it will be ellipse. If h square is greater than AB, it will be hyperbola. But if h square is greater than AB and a plus b is 0, then it is a rectangular hyperbola. So let's say a second degree equation in xy is given, 4 options are given. Then how do we figure it out? By doing this calculation. Remember that. Here, when you talk about a parabola, what will I say? This is how a parabola, standard parabola, y square is equals to 4x looks like. I'm talking with regard to the standard parabola. So what do we know here? This point here, 0, 0 is vertex. This line over here, x is equals to minus a is directrix. This point over here, a, 0 is your focus. And any line passing through the focus will be the focal chord. If I write a double ordinate means a line perpendicular to the axis will be the double ordinate. But there will be a double ordinate which will be a focal chord as well. So a line which is perpendicular to the axis and passing through the focus. It will be called the latus rectum, and the length of the latus rectum, I hope you know. Here, this is a, 0. So you pass a, 0 here in this point. so that you can find the L and L dash, and with L and L dash you can find the coordinates of L and L dash and you can find the length of lattice rectum. I'm sharing you the approaches. So I hope you got this. No confusions on that. There you got to remember something very important, the reflection property of a parabola. What do I mean by that? Let's say, I'll come back to this slide. Before that, let's have a discussion on it. Let's say a line is coming from infinity, a ray is coming from infinity. So after getting reflected from the surface of the parabola, it passes through the focus. If a ray passes through the focus or coming from the focus, touches the surface of the parabola, then it gets reflected and goes parallel to the axis of the parabola. Now let me come back to this part. This is something you can remember, you should, it will save a lot of time, but before that, t is equal to 0 will always give you the equation of a second degree curve, parabola, ellipse, circle, hyperbola. Here, let's say y square is equal to 4x is the standard parabola. On this parabola, let's say I wish to define a tangent with a slope m. Then its equation is given by y is equals to mx plus a by m. The condition for tangency here is that c should be equal to a by m. What is c? If the line is y is equals to mx plus c, then that c is equal to a by m. The third thing, the point of contact is given by a by m square comma 2a by m. The same is there in the normal. So for parabola, the normal at x1 comma y1 is given by this. I'll simply say that differentiate and get the value, because through differentiation you find the slope of the tangent. Negative reciprocal of it will be slope of the normal. So through that you can write the equation of the normal. This is in the t form, parametric form, at square comma 2at, and this is the equation of normal in slope form. This is what we have already discussed. Let's talk about ellipse. So for a standard ellipse, let's say the standard ellipse is given by x square upon a square plus y square upon b square is equals to 1. This is your standard ellipse. So we know this is a comma 0 minus a comma 0, 0 comma minus b, 0 comma b. It has two foci. Even a parabola has two foci. One is a comma 0, other is at infinity. So here it is e comma 0 and minus e comma 0. So for parabola, eccentricity was 1. Here eccentricity is e, which is less than 1 for an ellipse. So here you relate a square, b square and e square as that you write b square as a square times 1 minus e square. How I personally remember it, I always get confused that whether it is e square minus 1 or 1 minus e square. So I have developed a technique that for ellipse, eccentricity is less than 1, so you subtract it from 1. For hyperbola, eccentricity is greater than 1, so you write e square minus 1. So I'll write the same formula for hyperbola, but there I'll swap e square and 1. And that is how I remember it. For this is called the minor axis, this is called the major axis. So the length of the major axis is 2a, 2b minor axis. The distance between the foci is given by 2ae. Thank you. Now the next part is the distance between the directrices. So for corresponding foci, we have two directrices each. This directress is x is equals to a by e. This is x is equals to minus a by e. So I hope you remember. It also has a lattice rectum, a double ordinate passing through the foci, which is perpendicular on the axis, of course, which has the length 4b square upon a. Don't forget that. And the same fashion here, what you need to understand is this x-axis is the major axis because a is greater than b. But if a is less than b, the ellipse changes its, what should I say, shape. Its major axis becomes the y-axis and x-axis becomes the minor axis. So formulae also change. With that, let's move towards the next part, which is called the hyperbola. Now, what is true for the hyperbola? Just look at this. By the time I take a sip of coffee here. So, this is your origin center. How do you define the equation of the hyperbola? It is given by x square by a square minus y square by b square is equals to 1. For hyperbola also, you see its center at 0, 0. Its foci are at a, 0 and minus a, 0. These are the two axes here. I hope you know this. And again, you will have your lattice rectum 2b square upon a. What you need to understand here is the relationship between b, a and e that you should take care of is that b square is equals to a square times, remember this, e square minus 1 for a hyperbola. I hope you didn't forget that. From here, when I move ahead, I talk about the rectangular hyperbola. Now, when you talk about rectangular hyperbola, you basically treat it, or the one of the standard rectangular hyperbolas is xy is equals to c square. Its graph is drawn like this in the first quadrant and in the third quadrant. with the origin, it is symmetrical. It's of course has its center at the origin, but its vertices are c comma c and minus c comma minus c. This here y is equals to x. This line over here is a transverse axis, and this line y is equals to minus x here is conjugate axis. Of course, a lot other details are there about this hyperbola. Did you get that part? From here, I hope you know we have already started our WhatsApp channel. You can scan this QR code and stay up to date with all what we are doing. With that, it has been a great journey. I really loved interacting with you all, and I'm sure a lot of students are watching right now. They are still watching it. So I think before your JEE, this is our last interaction. I wish you all the very best. Take care of yourself. Don't pressurize yourself much, because you perform at your best when you are in the flow. Flow means when you simply enjoy the process. Take any example. If you like swimming, if you like playing cricket, if you like singing, if you like sketching, you enjoy it. And when you enjoy it, when you're not concerned about the result or the outcome or the comments about others, there you give your best. There you write your best. There you perform. You actually get into the flow. So find your flow. And trust me, this exam is not going to decide everything. A lot of things you will see in life coming in your way, way greater, way important, and way crucial than this exam. This exam is indeed important, of course, right, sincerely, but a lot of things will be there in life. So just go with your complete focus, find your flow, and enjoy the process. You will get the best out of yourself. As they always say, all the teams are equally potential, they have equal competent, they are equally competent, they have equal potential, but the team which handles the pressure well wins the match. That is what we are expecting out of you. Thank you so much. Take a good care of yourself. Ending this session. All the very best, everyone.